All right, thanks for everyone's patience. Welcome to this year's 6th edition of the VizWiz workshop. Wow. So this is the 6th edition, and like the first version, we have several goals that we would like to get out of it that are motivated by these two questions. First, what is the state of modern vision-based technologies and meeting the needs of people with vision impairments? Second, what are technical, social, and ethical challenges that we should address to improve such technologies? And so with that, our goals for today are going to be to track the computer vision progress on dataset challenges built with data captured by people with vision impairments, identify critical questions and priorities for the future, maintain a community for this work, and accelerate cutting-edge research, making it into market products, because we do have people from industry and academia here, so it's a great way for us to share ideas. As far as the organizers go, we have here 5 of the organizers for this event. It is largely possible because of my students here. So we have Chungyin, we have Everly, and we have Josh, and they'll be facilitating much of the event today. And then we also have Ed in the back, we have Jeff here, and myself. We are very lucky to have 5 awesome invited speakers throughout this morning. We'll be having Beer, which is over there, and Raul, Rowan, Brian, and Elissa. With that, I would like to share about our dataset challenges. We had 6 different challenges this year. A total of 76 teams competed on those 6 challenges. So that includes visual question answering, which 40 teams contributed to, answer grounding, which had 3 teams participating, single answer grounding, so predicting if there's one or multiple answer groundings, and that had 4 teams that competed. Locating private objects and images had 4 teams, and zero-shot classification had 24 teams, and then doing few-shot object recognition and videos had 1 team. So at this point, I'd like to share who the winners were. I'm going to show them in one slide. With that said, you will have a chance to hear from the winning teams throughout today's session. So with that, the challenge winners for the talks are as follows. So you can see here the names for VQA, VQA grounding, VQA single answer grounding, private objects localization, zero-shot classification, and orbit few-shot. So huge congratulations to the team. Because many of you don't know the names, and I don't know either, I'm not going to go through all of them, but they are listed here, and the winning teams will get certificates sent to them. And we will hear from the winners in blue throughout today, being SLCV for VQA, MGTV for VQA grounding, MGTV for single answer grounding challenge, Tele-AIA for private objects localization, HBNUE for zero shot, and EcoAI for orbit few shot. So with that, the schedule is as follows. We are going to have an overview of 3 challenges related to the VQA problem, and then the talks by the challenge winners, followed by a talk from Beer, a talk from Raul and Rowan, poster spotlight talks. And because the Arch building is so far away, we kind of slightly changed the schedule from here on so that we would have time to go and see the poster session. It's in a separate building. So at that time, if you haven't had a chance to go there, our organizers are going to have 2 shuttle waves to walk people over to help you find where the location is and walk you back so you can find your way back here. So we are going to facilitate that process. And so the poster session will go from 9:45 until 10:15. And then we'll have an overview of the remaining challenges, a talk from Brian Fischler, a comedian, and then from Elissa, a panel discussion and closing remarks. It looks like the schedule didn't get changed, but everything from the poster spotlight talks to later will be 10 minutes later. So with that, I'd like to now hand it off. Oh, sorry. Before that, we are very fortunate to have sponsorship from Apple. And so huge thanks to them for helping make this event possible. And so at this point, I'll pass it off to Chungyin to introduce our first set of activities.
Hello, everyone. Today I will be giving an overview of three challenges: visual question answering, answer rounding, and single answer rounding. Let's start with the visual question answering task, which aims to help visually impaired people to learn their surroundings by answering their visual questions. We have the VizWiz VQA dataset designed for this task, which contains around 32,000 visual questions. Each are provided with 10 answers from 10 different workers. This year, we have over 40 participating teams. I must say it is a very strong competition, and we are excited to witness a significant progress of over 14 performance boost compared to last year. Here I show some difficult examples where all top three teams provided incorrect answers. As shown, evidence still struggles for visual questions that related to long tail object, rotated text, and those querying about location. So the winner this year achieved an accuracy of 78.91% of accuracy for VizWiz VQA challenge. Congratulations to the winner team SLCB. And here is their presentation.
Hello, everyone. Today, we will present to everyone a solution for this challenge. The solution we propose is called LoRa Fine-Tuning for VizWiz Grand Challenge. Our team named as LCV comes from Shopline AI Research. The team members are composed of Bao Jun Li, Jiemian Huang, and Tao Liu. In this competition, we challenge three tracks as shown in the video. In order to reduce the difficulty of our work during training the model, we decided to use a unified tuning architecture to solve these three-track tasks. After completing the baselines of some models, such as Flip2, Lava, and Cogagent, we analyzed some related bad cases and found that the Cogagent model is better than other models. We suspect that the Cogagent model has high resolution and low resolution image encoders, making it easier to understand more details with smaller objects in the image than models with one image encoder. Furthermore, we found the DeepSeek VL model based on this feature that discovered multi-image encoder. We conducted comparative experiments between DeepSeek VL model and the other models with only a single image encoder, and a comparative experiment between DeepSeek VL model and the Cogagent model. Comparative experiments show that DeepSeek VL and Cogagent models that use two image encoders have similar effects, and significantly better than the other models that use a single image encoder. As shown in the video, through a series of ablation experiments, we finally selected appropriate high-resolution parameters and low-resolution parameters for the DeepSeek VL and Cogagent models. It is extremely difficult to train large visual language models from scratch or through general fine-tuning methods. Fortunately, the tuning method of the LoRa series has been proposed. We chose LoRa Plus as the tuning method for training models because LoRa Plus sets different learning rates for low-rank matrix A and low-rank matrix B respectively. It can not only slightly improve the effect of the model, but also speed up the training of the model. Through experiments, we found that the two model effects of DeepSeek VL and Cogagent can achieve optimal results when the ratio of the learning rates of low-rank matrix B and low-rank matrix A is equal to 16. We also experimentally selected the model low-rank values of DeepSeek VL and Cogagent to be 256 and 8 respectively. In the track of VQHR squad, we only used data with answer underscore confidence as yes to train the models, and used LoRa Plus tuning models for only one epoch. In the test standard effects, we ensembled the results of three models and finally obtained an overall score of 78.91. In the track of VQHS2, the tuning method is the same as that of task 1, but the answer we set is a probability string, and this probability is calculated according to the formula shown in the video. In the test standard phase, we assembled 6 models and obtained an AP score of 89.74. In the VQA answer therapy track, we set drop to 1 for data whose binary underscore label is single and 0 otherwise, and finally stringify the probability as the answer. And in the test standard phase, it achieved an overall F1 score of 85.64. In this competition, we not only used some innovative ideas from predecessors such as multiple image encoders and LoRa Plus, but also used some of our own tricks such as stringifying probability values. We feel that these innovations also indicate the direction of future development. VQA type tests still face some open challenges. There are difficult number type questions like the text per challenge, and other uncertainty type questions that still need to be overcome. That's all. Thank you.
No offense, but if you still think stocks, real estate, or crypto,
Okay, here I will show the second task, which is answer grounding. It aims to teach computers to automatically find the visual evidence in an image that indicates the language answer. The VizWiz VQA grounding dataset contains around 10,000 visual questions, each paired with an answer grounding for the most common answer to that visual question. This is the third year that we are holding the VizWiz VQA grounding challenge, and we have 3 participating teams. Overall, the top 3 teams still perform worst on the visual questions that with small region. And the winner this year achieved an LU of 75.11%. Congratulations to the MGTV team. And here is their presentation.
Hello, everyone. Thanks for coming to this talk. Today, I will present our method titled A Transformer-Based Solution in Answer Grounding. This is our overall network architecture, which consists of image encoder, text encoder, mask decoder, and answer decoder. In training, firstly, input images into image encoder to get image features, then input image features and question text into text encoder to get image grounded text features, and image grounded text features and image features into mask decoder to get a mask. Input the question text and image grounded text features into answer decoder to obtain the answer text. In inference, we only need to get the mask, so remove answer decoder and keep the network architecture in the red box. Specifically, for the image encoder, we use Ava ClipFit. For the text encoder, we use Roberta, and we have made modifications to each block by incorporating cross-attention, as shown in the figure on the right. This allows us to simultaneously incorporate text and image features. The structure of mask decoder is to add a segmentation module to text encoder, which primarily comprising a transformer decoder and an upsample module. The transformer decoder is constructed with 3 stacked transformer layers. Since the patch size is 16, we need to execute 4 upsampling steps. For the upsampling layers, a simple combination of bilinear interpolation and connectivity operations is employed to achieve the desired effect. The structure of the answer decoder replaces the multi-head attention in the text encoder with the masked multi-head attention. Moving on to the model training section, we not only utilized the official dataset provided, but also incorporated the TextVetX dataset into our training data. Regarding loss calculation, we employed 2 types of losses for model training: binary cross-entropy loss and answer loss. A DAM is used as our optimizer, and cosine annealing is used as our learning rate scheduler. In the data augmentation section, upon scrutinizing the dataset, we noticed that the questions often inquired about the color of objects. Consequently, we refrained from utilizing color-related augmentations such as color jitter, and instead employed simpler augmentations like horizontal flip, vertical flip, random rotate 90, and affine transformations. During the parameter tuning process, due to the use of a larger model and more data, we discovered that the model required a higher number of epochs to achieve full convergence. Therefore, we trained each model for 1,000 epochs. Furthermore, we employed training techniques such as exponential weighted average and pseudo-label to enhance the accuracy of our individual models. Finally, we trained 5 models using 5-fold technology. Moving on to post-processing, we employed a model assembling technique using a voting approach to integrate the 5 models trained. Because we found that the hard ensemble method, that is, voting, yielded superior results compared to the soft ensemble approach. In addition, we use test time augmentation TTA and inference, and the network output is binarized by adaptive threshold method. And then the maximum connectivity area is reserved as the final result through morphological transformation of dilation first and erosion later. Last year, we achieved a score of 0.728, which earned us second place. This year, our score has improved to 0.75. Overall, compared to last year, we have used more data, a larger model, better pre-training weights, increased the number of training epochs, and made some adjustments to training details and post-processing methods. These changes have resulted in significant improvements. That's all I reported. Thank you for listening.
Then we have our third challenge, single answer grounding challenge, which is to predict if a visual question will result in answers that all share the same grounding. The VQA answer therapy dataset contains around 5,800 images. This is the first time we are holding this challenge. And here I show some examples where all top 3 teams provided incorrect answers, as shown algorithms struggle to identify visual questions that we select. The winning team is still MGTV team, and congratulations to them. They achieved an S1 of 87.8 for VQA answer therapy. And here is their presentation.
Hello, everyone. Today, I'll present our method titled Transformer-Based Solution in VQA Answer Therapy. Our team from Mango TV will outline our competition solution across 4 aspects: task, model, training method, post-processing challenges, and limitations. Task objective: given a visual question image pair with answer, the task is to return the region in the image used to arrive at the answer. The VizWiz dataset provides visual images, questions, binary label, and answers. In the training set, all 4 components are available, but in the test set, only images and questions are given. Given that this is a multimodal algorithm and the training dataset is not substantial, we chose BLIP2 as our base model. BLIP2's pre-training on a large-scale dataset gives it strong generalization capabilities. Considering the limited amount of data, we only train MLP layer and last few transformer layers. In our model, for image feature extraction, we employ Vision Transformer, VIT, specifically removing its last layer and utilizing the features from the penultimate layer. The input resolution for VIT in this configuration is set at 224 pixels. However, it's worth considering switching to the Vision Transformer architecture utilized by Segment Anything Model, SAM, which operates at a higher input resolution of 1024 pixels, thereby enabling the extraction of more intricate image features. For linguistic feature design, we introduced learnable query embeddings as inputs, shaped as B32-768, where B denotes the batch size. These queries undergo self-attention, SA, allowing each token to learn what it should focus on, enabling each part to discern its own areas of interest within the context. Subsequently, through cross-attention, CA, these queries interact with the extracted image features. Finally, the processed information is passed through a multi-layer perceptron, MLP layer for decoding, integrating the visual and linguistic cues effectively. For model training, we used the official dataset. We employed binary cross-entropy loss and answer loss. In data augmentation, we avoided color-related augmentations and used simpler ones like flips, rotations, and affine transformations. The model required more epochs for full convergence, so we trained each model for 150 epochs. We also use techniques like exponential weighted average and pseudo-label to improve accuracy. For post-processing, we used a voting-based model ensemble, which outperformed the soft ensemble approach. Individual models had different hyperparameters, utilized five-fold data, random seeds, diverse training data, top 3 models, and different architectures. We also applied test time augmentation, TTA. The paucity of training data shifts the focus during model training onto mitigating overfitting, thereby diverting attention away from in-depth exploration of the model itself. Increasing the amount of training data is advantageous, as it not only alleviates the overfitting concern, but also stimulates more extensive research into multimodal large models for this particular task, enhancing their performance and deepening our understanding of their potential. That's our solution, thank you.
Yeah, with that, we conclude these 3 challenges, and we are very excited to have our first speaker, Sora Beer Champion, who is a computer vision researcher from Google's DeepMind team, where he contributed to the Google's Gemini and Pali. I become familiar with Beer through his famous papers, including InfoSeek VQA and CC12M. Fun fact, I'm very fortunate to be interning with Beer's team this summer, and Beer is incredibly insightful and will bring us his talk towards vision and richer language. Welcome, Beer.
Great. Thanks, Shongyan, for the introduction. Thanks, all the organizers for organizing this great workshop. As Shongyan mentioned, my name is Beer, and I go by Beer, and you can call me Beer. And I'm with Google DeepMind now, and I'm going to be talking about vision and language research that I've been working in the past 5 years or so. And this is joint work with many people at Google and OSU. All right, first thing first, why vision and language? I hope I don't have to convince this audience, but let me just say one sentence. We want to be able to communicate with machines, grounding what we talked about in the real world. So vision and language is important. And in the context of this workshop, since the machines act as eyes for the blind and visually impaired users, this research is even more important. So what do I mean by vision and language? In this talk, my main focus is going to be the boring image and text. And in particular, these 2 tasks, image captioning and VQA. And I like for people to be on the same page. So let me just get it out what it is. You want to come up with a natural language description for an image in image captioning. So that is popular benchmarks since 2015. Coco caption, no caps, localized narratives. This is just as an example. Visual question answering or VQA. You want to answer visual questions about images. And again, similarly, there are so many benchmarks there, at least popular ones here. Of course, VizWiz is there. I'm sure there are more than 100 benchmarks at this point. Right, so what do you think about when I say language and vision and language research? So if you look at the benchmarks that I just kind of showed you, they oftentimes originated from the vision community. So if you look closely, human language in all its glory is not there. So expectation is like this, and then reality is kind of more like this, where vision is kind of the first class citizen and language is not. So in fact, Chris Manning, professor from Stanford, NLP and linguistic professor, he gave a talk at BK workshop 5 years ago. The title of the talk is Making the L in the VQA Matter. And this is basically one call for elevating the role of language in vision and language research. So this is great talk and check the slide there, but I mean, just to kind of summarize, if you look at a popular VK benchmark, VKV2, can kind of see that, oh, okay, there's a lot of like yes and no numbers, one word answers, right? And if you look at the questions, usually this is one step inference kind of questions. So language is not very complicated. So Chris and his student, so Drew Hudson, came up with this GQA data set where they basically first try to at least, make the questions more complex, right? So you can kind of do reasoning. And similarly, that worked, NLVR is kind of, NLVR2 is similar kind, where you try to say whether this statement about images is true or false. But yeah, overall, basically, the main idea is you kind of have to do visual reasoning through language. So that's not my work, but basically this is kind of one way you can elevate the role of language. Right? But there should be other ways, and it's going to be today's talk. Right? So the first thing that came to my mind is specificity. So what do I mean by that? So I took this figure from this paper from Princeton, and this is Coco Captions data set. The caption is a man holding a tennis racket on a tennis court. And if you look at this caption, it's applicable to kind of so many images, right? Actually the one in a top, middle, top row, probably not correct. It's not a man, but okay, you get my point, right? As someone who's really into tennis, this is kind of disappointing, right? I want to be able to say, oh, that Alexander Kopolov preparing to serve, and then people should know Federer, just hit forehand and Nadal, and you can say about clay court, hard court, grass, can say things about tennis racket. There's so many things you could say, right? One way to kind of think about solving this is through large-scale image text pre-training data. Because once you kind of scale things up, and those things you kind of obtain in the world, you can kind of increase specificity that way. So this is one of the works from our team, conceptual captions, where you collect image alt text from the web. So 3 million. And then 3 years later, I got a chance to kind of extend this to 12 million and kind of do not think about it as image captioning, but more as kind of a pre-training data. And just by doing this 4x scaling, you can kind of cover a lot of these long tail concepts defined here as, this classes in no gaps. But you can see we can kind of, cover all these words and phrases. right? And now, for example, you would be able to mention that it's like cute, you have the vocab that is cute, bagpipes, so on. And the story goes on, right? From 2021, it's been 3 years already. So of course the scale is gonna go to 100 billion, like in no doubt. All right, that pretty simple stuff, specificity. I'm not saying that that's kind of how you solve specificity, but it's kind of one way you could go about it, right? So let me switch to the next thing I was thinking about, syntax understanding. So this is language in pixels, basically. Okay, with VQA, everyone is familiar with, I think. So I personally have gone through a lot of examples in VizWiz data, and I can kind of say that these examples are representatives of what is happening in VizWiz. Basically, you have a bunch of kind of like a single object, like usually products, and usually the user wants some information about these products, right? And usually there are texts that are kind of involved here. You can kind of think of solving this as very, very fine-grained recognition problem, since there's like usually main object there, right? And I kind of worked on this a little bit in 2019. But yeah, basically the main idea is basically think of this as instant level recognition. So that's a banknote from, I think, Canada. I'm not sure, but okay, correct me if I'm wrong. And then barbecue sauce, that's a product. If you can recognize this product, then you can say this barbecue sauce, right? So that's concept of this ultra fine grained visual features, right? But obviously, fine-grained recognition will only get you so far, right? Because it's not going to be robust, especially since these images are often blurry. And, there's news product introduced every day. And, yeah, basically, the point is if you want to be robust, then probably it's better for you to be able to read text. And this is which brings me to syntax understanding. So then, not surprisingly, VizWiz kind of inspires other data sets creation. And in particular, this one I show text PQA. It's kind of requires syntax understanding. And here's one example. What does it say? Near the star on the tail of the plane, jet, right? Okay, how do we solve this? Seems that you have to be able to first recognize text in an image. So this is kind of like OCR. And then kind of understand that, say here in this example, chat is printed on the tail of the plane near the star. Kind of want to put this text in the visual context, right? So there's these two essential capabilities that I want to solve. And basically, this is the main idea of our papers at SCCB last year. So we have this thing called split OCR, and we try to do syntax modeling by transferring from the off-the-shelf OCR. So first, to kind of turn these pixels into language, and we try to model it. So just to get into a little bit more, to provide you a little bit more details. So basically what we do is propose this press to the recipe, where we just add this like pre-training step before you either do syntax VQA or syntax captioning. But our main goal is to make sure that we do syntax recognition and try to connect this syntax to the visual context from the beginning. Right, and so this pre-training stage would contain split OCR, and then VK or CAP, depending on, class that you're gonna do at the end. But basically, so I'm gonna explain all this in a minute. But basically, the main idea is to add this pre-training step. Right, so what is split OCR? It's very, very simple. In Word, given an image, you get like run OCR, off-the-shelf OCR system. Here is like Google OCR, and then split it into 2 chunks, and then put the first chunk in the input, predict the rest, along with other things. Okay, simple enough. I'm not going to go into the detail how it's split and so on, but okay, this is split OCR. And then VQA and CAP, this is kind of more of a standard thing where you either do VQA or captioning with the OCR tokens as input. All right, so recap, split OCR, VQA or CAP during pre-training. Okay. And you can obtain OCR signals from many images, no problem. We use CC basically 3M plus 12M, so 15 as a pre-training data. And then CAP, we use the same data. And then VKA, since there's no data, we use syntax, VKA, ST, VKA there for pre-training. So, okay, let's look at the result really quickly. As I told you previously, the baseline is basically this VKA or CAP with OCR tokens as input. Right? So I get this number. And okay, of course, once you apply Presto to get all this nice gains, even non-VKA V2, you get like also small gains there, right? So with VizWiz 62, it seems that in the challenge it's like 78 now. So it's very, very crazy how fast, okay. The progress. Right, and okay, same story for captioning. All right, one thing I want to highlight is that if you just do OCR, we don't split. I predict the whole token like OCR tokens, right? What's going to happen is you're gonna underperform. And here, as I show you, even if I get rid of the second stage, split OCR is better. If I add the second stage, split OCR is better. And then especially, let's say you don't have OCR tokens during fine tuning. Split OCR gives you inherently stronger models at syntax understanding. Yes. So I don't have a clear answer why. I know one of you is going to ask why I don't have a clear answer. Why exactly? But the hypothesis is that OCR has probably put too much emphasis on syntax recognitions, but not connecting syntax to the visual context. All right, and then side story here. Probably last year we did OCR during pre-training. And then, okay, we did all the experiments and then, okay, Poly X split OCR. So Poly X is the process session on Thursday morning. Well, there are a lot of Poly authors here, including Tishan, first author. So yeah, please come check it out, paper. How much time do I have? Okay, I try to go quick. Next part, interrogative language. Basically, this is VQA. I'm just like, but yeah, motivation is creating VQA data is costly and time consuming. So I'm switching gear now. So, okay, this is kind of third way you can elevate the language, right? Okay, this statement, I think, I hope it's true. And then, okay, if I were to collect VKA data, do I ask humans to come up with question and answer one by one? Or based on this observation that, okay, it seems that VQA signals overlap with signals in the image captions. So isn't it more cost effective to just collect captions in one shot, a few shots, right? And go captions here. But even better, you can actually get a lot of this image text in one, right? So this single caption, you cannot get it for free almost, right? So it's even more cost effective than asking human annotators to come up with question and answer pairs. So we had this paper at NACO last 2 years ago, where we tried to rewrite each image captions as multiple QA pairs. So turning declarative form captions into a bunch of question answer pairs. How do we do this? We have something called VQ square A. Given a caption, two pairs are laying down on the ice. Consider this caption only, ignore the image. Use your favorite NLP tools to extract some answer candidates. Add some default answer there, yes or no. Given these answers and the caption, I use textual question generation to generate questions. Given questions and caption using textual question answering to answer this question. Do some answer like, check the score, and then get rid of the things that kind of do not match. And then the rest of the question you have here, you pair them back with the image, you get VQA data sets. Just quickly showing examples, a bunch of the captions there at the bottom. And then here, syntax understanding, right? You want to create, you can come up with a bunch of these questions, right? And the same thing, okay, CC3M, this caption you obtain, for free, and by just looking at this one caption, you can come up with all these many questions asking about material, property, color, about this image. And just a quick note, if you use this data set for training, and evaluate cross data set, it's going to be more robust using data generated display. All right, very, very close to the end. You cannot talk about language with just English. So this is my last part. What is this data set? VizWiz. I hope you all recognize, right? And this is non-negligible portion of VizWiz. It's like this, right? So it's not just it would help, right? Okay, but maybe there's like small English words there, but it would help if you understand non-English language there. Right? And I look at the answer, a lot of you get a lot of unanswerable answer for these types of images a lot. Right? So we have an extension of the previous paper that is talked about, where we try to extend this to the languages, and we call this Maxim. And it's very simple. We try to basically, again, leverage some tools out there in the language community. And basically add translation and human in the loops. And this is EMNLP last year. Okay, let me just explain quickly. Given a caption in Chinese there, fly machine translation, you get Japanese frowning with tomato. Apply the same approach that I just talked about. You get question and answer in English. machine translation again. You do have to involve humans next step because translation can introduce some artifacts. But you can do some kind of checking there as well, like some consistency check as before. But in the end, again, you get this nicely written question and answer pairs in Chinese. And then in many languages, here, French, Romanian, Hindi, Thai, Hebrew, and Chinese. Right? Conclusion, I hope I have convinced you that you can elevate the role of language in vision language research. And how do you do that? Think about tasks, right? NLP tasks, vision tasks, and leverage them and combine with other ingredients if you need to. Object like training objectives, cycle consistency, human in the loop. What else? Well, this is the LLM era, right? So besides all the aspects that I have talked about, you're not gonna get away. Okay, you cannot. Yeah, comprehensiveness, basically long form answer, is going to be there. So you should kind of think about this. Obviously, it seems eval should be the highest priority here, right? And I have list 3 words here. This is not my word, but I think this is kind of like exciting direction. And we recognize actually by Chongyan. I really like it, And then Dashi animation words are basically a very, very dense, detailed description of images. And I think this is very, very exciting direction. Thank you.
Anyone have any questions for here?
I would love that you were talking about elevating language, and it seems that with modern transformers, we've gotten into a place where language is starting to become dominant and starting to create hallucination. Can you talk about where you think elevating language should stay in the picture versus now we need to elevate vision and where you see all that?
Yeah. Yeah. So I also talked about. Okay, can you guys? I also talked about comprehensiveness toward the end, right? And I think that's kind of related to what you just asked as well. I'm not sure whether we can exactly solve hallucination by elevating vision. It feels to me the first step should be coming up with the right eval, and go from there. Hope that answers the question.
About the last part of this, like Dolce, I think that researchers spent a ton of time manually creating those event captions.
Yeah.
Like, have you had any experience creating that in the expensive and is it a multi-step approach? What's your take on it?
So, yeah, I have not been involved directly with this work, but I know the first author helped both of the papers, and they did have to spend a lot of time to make sure that things are good, right? I would say it's more opportunities for you to come up with the right way to, like most efficient way, most effective way to come up with these questions. I don't know, with this description. Yeah, how human and machines can collaborate. Yeah. And you can leverage Gemini, GPT-4, of course, yeah, for this. Yeah.
Thank you for that report. I'm interested in the part of converting the image caption into QA. So my question is, if we already have image captioning, we like to change the QA.
Sorry, I couldn't hear the last part.
So my question is, we already image captioning, so where we
Oh, why do we need to do VQA? That's the question. Well, the visually impaired ask the questions, right? In the end, that would be interaction. Sometimes you want some specific information, right? So I don't think you can ignore the VK part completely. Is that a question? Sorry.
I mean, the comparison with image captioning. Because you mentioned how you convert your image captioning to in that thing, we already have an infection. Maybe for application, you can think about, I wonder if there are some new challenges.
Right. So yeah, it's actually just about the forms of language. I agree. So it's not like you like things like specificity, for example, image captioning, by transfer learning, let's say you have a lot of pre-trained data. Yeah, probably you can do VPA better, right? But this is kind of about in the end, the form, in the end, if your application is you require this interactive forms of PQA, I think it could help there. Also creating benchmarks, right? It doesn't have to be pre-training data, right? Can think of, okay, what if I want to create the weekly benchmarks really quickly? How do I do that, right? And yeah.
Okay.
If we have no more questions, thank you, Beer.
Thank you.
All right, thank you so much, Fear. Cool. I'm excited to introduce our next speakers. First off, I'm a white man, black hair, green shirt. And yeah, so we have an exciting next talk coming up. Oh, yeah, there we go. Cool. So I'm really excited to introduce Raul and Rowan from OpenAI. Raul is a graduate from University of California, Berkeley, most known for the GPT-4 stuff, had a productive stint over at NVIDIA. Rowan does PhD just up the road from University of Washington, spent a lot of great time at Allen Institute and interested in all things multimodal, probably best known for GPT and the Merlot series. And yeah, they'll be talking to us about challenges in deploying omni models and assistive technology and where we are and where we go from here. And yeah, I'll hand it off to them.
Cool. Good morning, everyone. Yeah, today we're here to talk to you guys about or share some of our experiences deploying GPT-4V and GPT-4o, and particularly like getting it to work well for the blind and low vision community. And in classic academic fashion, we have more content than time, so let's get to it. One of the big parts of getting this to work right was iterative deployment and actually working closely with the blind and low vision community over the course of like multiple years and honestly over the course of even multiple models. And this was actually quite a transformative experience. We didn't realize this going into it, but co-developing these technologies together actually made them both better. You know, getting things to work well for the blind low vision community, it required us to be thoughtful and get to a solution that worked for everyone. And really, we're trying to put the G in AGI, so we need to be general here.
Oh, you meant to get supposed to like.
Oh, is it not loud enough?
Yeah, we
Oh.
can't hear with the mic.
Sorry.
Hello? Okay, it's definitely not working. If you can speak loud, I'm gonna go see if I can find that. Just, can you hear us in the back?
Yeah, how's it back?
Is this
Yeah.
You can speak
Does
loud.
that work?
No, I'm gonna go ahead and try to find some help.
Oh, okay. No, it's okay. Hello. So one of the, where was I? Oh, yes. So one of the reason why this was a really rewarding experience is to get this technology to work for the blind and low vision community, we really needed general models. If you look at this task distribution, of Viz, it's gone. If you look at this task distribution for VizWiz, there's quite a few tasks on there, and this is because we have to be able to provide a similar level of utility as the human visual system. This is a pretty hard baseline to meet. They're pretty good. And we found actually quite a few challenges in getting this to work. But there's usually 3 flavors of these challenges. Challenges stemming from the generality of the tasks and the fact that the users can ask anything. There's also this other issue we realized is that users have limited clarity on the model input and judgment of the model output. We as computer vision researchers, every now and then we'll dive into our data set, play with the model, see what parts of the data set it's failing on. You can't really judge model input and output to the same extent in these settings. And lastly, to get these models deployed in the real world requires adhering to some content policy and safety standards. And we found that this had to work in the general case as well as be thoughtful for our blind users. So this area of deployment has honestly been a multi-year effort from the entire research community. We've gone from pairs of models, or models that are pairs of modalities such as GPT and codex, which is text in, text out. You have audio models that are audio in or audio out. And you also have models that go text to image, such as DALL-E and Sora. And over time, we've been adding, more modalities in one model. We've been adding image and text as input. So this is the case for GPT-4V. And then we've also just recently shipped models that have all the modalities together. And that's GPT-4o. So a little bit about the talk structure for today. We're going to dive into just a little refresher on GPT-4V and set some technical foundations here. We'll talk about some challenges and trade-offs. We'll then also hand it over to Rowan to transition to GPT-4o. And, we'll then talk about where we go from here. So one of my favorite examples that I feel captures why this paradigm is important is this one right here. This is just a simple sketched circuit diagram from your electrical engineering class. This is your standard hello world for electrical engineering. And this is actually kind of difficult to communicate verbally and enter into a computer. You got squiggles, you got a layout that matters, and it's all important. But when you communicate it visually, it's very easy to understand what's going on. Endowing language models with visual input gives us a lot more expressivity than we've had in the past. You can process information that's just not easily communicated. And unfortunately, humans for millennia have been putting a lot of information into visual stuff. Drawings on ancient scrolls, I don't know, Leonardo da Vinci's wild diagrams, what have you. So I think it's quite important that we have these paradigms with multimodal input. And the data format itself of the more multimodal models is actually even more flexible. For example, this is how you might process a Wikipedia page about the solar system. You can freely interleave text, image, more text, more images, and it's quite compositional. And this lets you express a lot of different tasks. And it's much closer to how we as humans may interpret a web page. It's not just a image to text pair, as many of our computer vision tasks are.
We also in GPT-4V have a high-res mode to allow flexibility to handle images from various domains. Unfortunately, not all images come in beautiful 256 by 256 squares. Yeah, and to support images like this, one possible way you can do it, leveraging the compositionality we showed on the last page, you can show a zoomed out square of the entire image, followed by some prompts afterwards. And we have this conveniently exposed on our API for people to use. This also gives you like some interesting knobs to turn here, like you get to use more tokens to process an image, which means you're using more compute, more attention to process that image, and oftentimes that can result in like better performance from recent tasks. So it's really quite flexible. Unfortunately, with flexibility comes trade-offs. So going back to some of the challenges that I was mentioning earlier, generality of tasks, users' limited clarity on model input and output, and the difficulty of navigating content policies. So going back to the first one, this task distribution from VizWiz is pretty robust. But as we found, like actually going to the real world with our deployment, there was a myriad of tasks that were not really covered. And we would like to use GPT-4 wherever we can. If you could just sprinkle it everywhere, that'd be phenomenal. But the reality is, like, it's expensive, it can be slow. Yeah, like this isn't always feasible, to get the UX right for our blind and low vision users, you also want like latency to be good. So in early stages, we're talking like, can we consider smaller models, can we make task specific dense models? And this was difficult, because like generalization may suffer. There's also this question of like, what is the task distribution? Where is the boundary of tasks? What do you distill on? How do you switch between tasks? And also like users may not even know what task they're in because we have this additional complication for this set of users. For example, here, like I've pulled some examples that we have in our blog and my dog. We have a meme. There's like an explanation of a meme because oftentimes like people want to relate to others and like hear about what their kids are laughing at or whatever. We're all students. We all want to learn. So some of our users would still like to like handle education tasks that are maybe a little too difficult for them. But in this case, this is a French physics exam. What if you had an English language model? Like, would it be able to handle French physics exam to the same extent? And there's also this very, very common request we got from a lot of our users, which is we just want to know what our loved ones look like currently. The last time they saw them, they might have been kids. But is that like a captioning task? Is it like a story generation narrative task? Who knows, right? Like it's kind of like a gray area. And so we obviously didn't really come up with any solutions there. We just kept using the big model. And there was this other issue of like, okay, we exposed this low and this high resolution mode. One is more capable, one is less capable, but lower latency. How do you select? Developers like this freedom, like if you are just like I can't think of a task, but if you have very straightforward tasks, you would totally prioritize the low res. It's even cheaper, so go for it. But the problem is like our blind and low vision users, like a lot of the times would use it to like read nutrition facts or like small writing that is taken at an angle. And for this, we needed like the high res mode. Like just by a show of hands, well, I don't think actually anyone in the room could probably read what's on these bottles, but if you squint, it's still really hard to see the one on the left, but you can see the one on the right if you look closely. So, you don't even know the font size a lot of the times. And like the naive solution here is like always to use high resolution, and that's what we ended up doing because we want to prioritize quality for these users. And honestly, it's like still much cheaper than like going directly to like a human in the loop.
It's also much more liberating. A lot of our users said to use this technology, they feel like they don't have to rely on others. They can be more independent. So we're like, okay, this is like a fine trade-off to make. In the future, maybe, you like have it be dynamic, let another model choose, develop a model that itself can choose. I mean, taking our human eye as a baseline, the human eye is dynamic. So it stands to reason that eventually we can get to systems that can do this as well. One of the things I touched on in like the previous slide was a lot of people wanted to be able to like, interpret their loved in they wanted to show pictures of like their loved ones or people on social media, get captioning, like identify people. Unfortunately, this kind of gets into thorny areas for a lot of like content policy reasons. The last decade of big tech rollouts of AI have not necessarily like instilled a lot of goodwill and have led to a lot of regulation. We also like know that data set biases are a prevalent issue. So, we at OpenAI tried to take safety very seriously, and like we have a myriad of like safety mitigations in place, both at the system level and at the model level. But the ability to see or recognize someone's face, it's like something we all take for granted as sighted individuals, and like it's just not fair to our users to like deprive them of that if there is this technology that can do that. So we really wanted to find an equitable experience to blind users. And to do this, we actually had to like conditionally modify safety mitigations based on some information from a secondary system. Is the user blind or sighted? What geolocation are they in? And we basically had to marry the model system and like this secondary system together to make this happen. And it had to be tolerable. So initially, we tried like an ensemble of methods. We had secondary systems and models making judgments of like, is there a person in this image? If so, do X, do Y. And our safety research team, myself included, were like, these are awesome. Like they're nailing in all our safety evals. But as like we went to the real world, there were so many false positives. For example, here on the right, I created an image from Dolly to example to illustrate this. Like this is a mock cereal box we'd like to extract nutrition fact information from, but it has a person on it. It's also not even a real person, it's a cartoon. But like so many like secondary systems and models would flag this as a person. And then you're basically like inducing undesirable behavior in your model, you're impacting capabilities. And like addressing this at the model level is hard because then you're sort of locked in, right? You can't change it, you can't be flexible, you can't modulate it based on the secondary information. So this was so frustrating to our blind beta testers because actually before we rolled out these changes, they had unrestricted access. So they were like, what the heck, guys, this is horrible. What did you do? We got a lot of passionate messages. Eventually, we actually came to quite an elegant solution that we thought of at the last second. We realized we're using all these like really tiny models to do this and regulate this very big, powerful vision language model. And we're like, wait, we have the world's state-of-the-art vision language model. Like, why don't we just use that vision model to process these images? Sorry, it's really funny in retrospect, but we were already passing the image through the model anyways. So we're expending the compute, we're going to do it anyways. And, we can't be there to judge the nuance on every single case. So let's just give the model instructions and have it do it. And dang, it's good. It's way better than like any of like the rule-based systems that we could have come up with. So, this was like a phenomenal way to like take a really powerful, capable, expensive system and basically actually get it to do our job for free. So that was a pretty fun one. And lastly, hallucinations. I think many of us in like the AI community throw this around and like, oh, I think we care about it because we're like, oh, it's going to make the capabilities bad. I can't like, trust the model output. Like it's not actually going to work when I need it to work. But that's fine for most of us because like we can see that it failed and like we can judge that it failed a lot of the times for a lot of the tasks we
can see hallucinations for. However, a lot of our blind users, they can't. And in fact, like, the only way they know that there's hallucinations is like because they know the answer already and they're just stress testing the system, or they actually have a human in the loop because Be My Eyes, our launch partner, had that ability to have like a human in the loop and call humans for help. So, in the rollout, we had to like tell our users to not rely on AI for critical tasks as much as they wanted this to be independent. We definitely did not want them to replace their guide dogs with GPT. We're not there yet. Dogs are amazingly intelligent. Artificial intelligence not that good yet, but maybe one day. And ultimately, like reflecting on this, like in retrospect, it was like a remarkably fortuitous partnership. We started out just wanting to do some good, but actually they like forced us to be our best here. And these issues I'm describing, like with the content policy, like that's difficult for them to deal with. But then, everyone else like basically got the final solution for free. People didn't really hear about this afterwards. No one really complained about it. Yeah, none of you guys have probably sent us the level of like feedback that we got in those early beta tests. The ultimate deployment didn't have any of these issues. So we're very grateful for our partnership with the community. And now Rowan.
Thanks, Raul. Yeah. So yeah, I'm gonna try getting right to it. Yeah. So Rowan at OpenAI also talking about GPT-4o, and I want to do a little bit of showing, not telling, or not just telling. So I've got the demo here. Let's see if it works.
Okay.
Hey, what do you see?
Looks like you're at a conference, maybe speaking or presenting, and that's quite an audience.
But yeah, that's pretty cool. Can you tell me what conference I might be at?
Looks like you're at the CVPR 2024 conference in Seattle. Your badge and a screen in the background give it away. How are you finding it so far?
It's pretty cool. I mean, it's kind of early right now. So wait, how do you think the audience is feeling? What do you seeing?
The audience seems engaged and attentive. I see some and some interest. It looks like you're doing a good job keeping them engaged. How are you finding the energy in the room?
Oh, it's pretty good. A lot of people have their. Oh, sorry. What's that?
We asked that.
Yeah. What do y'all think?
Yeah. Seems like and enjoying the session. It's always good to have an enthusiastic audience. Are you presenting something interactive?
I'm presenting this demo. That's pretty interactive, isn't it?
Definitely. It's great to see them so engaged. Seems to be holding their.
Yeah. Cool. Anyway, so probably could go on for a little longer. Yeah, but okay, so I want to talk about. Okay, I had a little backup video in case this one doesn't work. There's a video on YouTube. I highly recommend it by Be My Eyes, where they played around with our system in London. Really cool stuff. Oh wait. Whoops. Oh, whoops. Sorry. Okay. Okay. Yeah. So I'm going to talk about something really fast that I have almost no qualifications on. That's UI design. And I think this is like really important stuff, especially if we think about like vision, AI capabilities and all that. On the left is like the standard ChatGPT screen, I guess. There's a lot of like little icons, like taking a picture or uploading a picture that you already had. And I think the main thing that we were kind of iterating on, or one of the main things for this demo is like, what should the UX look like, and how can we make it more accessible and fluid to interact with? And so when you enter into this demo, there's no camera button. It's already, well, I guess, okay, there is a camera button if you want to like flip into like selfie mode or not selfie mode, but it is the system is taking the photos. They're taking each frame. And I think that's like there's like a really subtle thing that took a little bit of us time to iterate on. Like it's kind of weird. It feels very simple, but it actually took a while to iterate there. But in return, it actually unlocked so much. And to take a look at what it might unlock, I literally went to the VizWiz dataset viewer and I found the first image. I mean, I could have looked more, but this is actually this kind of shows my point. And this image, this question is unanswerable. But why is it unanswerable? Well, like this person had this need, I guess, of like what's in this can. But the the ontology of the problem, in other words, like, them taking out their phone, fumbling around for the camera button, obviously, if they're visually impaired, it might be, kind of hard to like figure out which frame to take, right? Meant that this question is unanswerable. So like, in other words, according to the data set, there's no way to answer it, but that doesn't mean this can is unreadable. So it's possible that for a split second, their phone was like processing the right pixels that we needed to process. It just kind of got lost in the ether. And so maybe there's something to think about in terms of what UX, like with the right UX, maybe we could actually have solved this question. And so maybe it wouldn't be unanswerable. Of course, video introduces these other these other like unanswerable factors, and one of these is this externality due to the cell connection. So before the demo, I was like really hoping, gosh, I hope the Wi-Fi is okay. I hope I can like send all the frames over to the other end and have them be in really crisp, high quality. Because if not, it turns into a blurry blob, and then as a result, it can be pretty challenging. So yeah, this is a tricky thing. And then, if you're in this like resource constrained environment on the edge, well, what do? There's probably a whole lot of challenges there. We have not like there's so much more that we need to explore. Yeah, and so like the UX also means other things, right? If it's cheaper to communicate or to interact with visual AI, maybe that unlocks new capabilities. If sending each frame is cheaper, maybe we can send more frames. Then streaming audio, etc. That's like another realm of accessibility. Getting the answer in audio rather than in text. All these like things I think are like really important. And then sort of also as the capabilities change, that also interacts with how the UX changes. So maybe like how much do we want to think about low or high res images? Is that an implementation detail that most people want to think about? Probably not. So start meeting somebody with AI companion. Okay, future work. Okay, so a lot of people ask me what should they work on. Well, I think that there's a lot that's not solved. Obviously, so many questions under safety. We all got to the tip of the iceberg in his part of the talk. I talked a little bit about UX. Obviously, we're talking about UX improving and capabilities improving, and then the capabilities driving the UX and the UX driving the capabilities. And so there's ML improvements too. I talked about some new failure modes from putting all these like end-to-end parts together, like network connectivity. So if anyone wants to go ahead and go everywhere in the US or actually everywhere in the world and upgrade all the cell towers to be like 6G or whatever, please do that. Make my life easier. I won't have to think about it anymore. But in reality, probably it's sort of like I find it kind of exciting to be like traditionally ML vision NLP person and then thinking about all these problems with all these different hats. I never knew that much about systems and latency and on the edge stuff, and now I have to know a little bit more. Yeah, and then obviously UX and safety also trade off as well. Yeah, and just last slide, just like quick shout, I wanted to say like, yeah, like all of this kind of relies on community efforts for data commons, eval commons. So it's really great that VizWiz exists as this like public benchmarking resource to build off of. Yeah.
Thank you for the awesome talk, Rowan and Paul. We can take a couple questions from the audience.
Yeah, go for it.
My question is about flexibility versus safety and robustness. So you use this example of person on the box. I remember back in the days when I wanted to use GPT-4 Vision to say, what is this coin? And there was like green code on the back of the pen, and it was like, nope, I can do it.
Yeah.
And right now, you decided to pass the image straight to the model. Isn't that more prone like jailbreaking and kind of like getting out of that robust system that you designed?
Yeah, I mean, it can be, but the thing is like, oh, hello, okay. It can certainly be more jailbreakable, but I find that actually like the extreme that you have to take the older systems to ends up just like, you know, it basically makes the current system unusable because you end up just refusing everything. Like, there's no point in like building tech that like is not usable because then you actually haven't correctly built the tech. So it's difficult. Yeah, like, and I think like people with safety sometimes are overzealous and just like completely like lobotomize the system. Yeah, it's definitely like a tricky line to toe. And honestly, like, I don't know how people in like our content policy and safety teams do it, but I think that they've done a great job at, you know, enabling others to use the technology over time and sort of restricting or lowering the, yeah, reducing the cases of like over refusal while still like keeping the system safe. It just took a little bit of time to get right. I know, sorry if that does or doesn't answer your question.
Yeah, so I think in order to be so flexible, complicated system, we need to know what's the intention of, like, we need what's the key compress, like this can be reflected in both single image wraps and video apps. So for example, and users are interested in certain parts of video, but we don't know this ahead. So I think this is a key question.
Yep. I mean that you hit the nail on the head where like you don't know a priori like what you want to the model to focus on. You don't know if you want it to be low res, high res, which pixel or which frame the image in the video to select. I don't think we've solved any of those problems here. That's why I left it in the future work section for hopefully one of you guys to solve. But I think given the trajectory, hopefully someone will. And if you plan for that, then the remaining thing to be done is make the data and eval comments actually reflective of the community and make sure that it serves the community.
Totally. I mean, one of the, echoing what Raul said, like, I mean, this classic paper and vision of like unbiased look of data set bias, right? I can't remember, I'm probably butchering the name, many years ago, right? And like every data set is like this micro view of the world, right? But like when a user comes and asks the model for a question, then really, if this was like we shouldn't be answering just based on that question. We should be answering based on the whole trajectory of their life. It's a little bit hard to compress in a data set, so we have to make assumptions, but then which assumptions should we reevaluate? I don't know.
How do you make a decision to deploy a model to production? And this might be more complicated with more modalities, more types of evals. And if some metrics go up, some metrics go down, how do you kind of move forward from a holistic perspective?
I mean, there's the capability section side. I mean, we want number to go up. That's a very straightforward, way to decide is the model shippable or not. You look at it, you're like, this is not worth people using, or it is worth people using. And so the capability side is easy. The policy side, I honestly am not qualified to answer that question, not because I don't know, but because the other people that we rely on to make that decision are so well read and thoughtful that like, honestly, like, dude, I trust our safety and policy team so much. And having worked with them, to address some of these issues around like safety, like, and seeing the amount of like thought and consideration and like the myriad of the myriad of problems that they've thought of and like are forcing us to address, like, yeah, like I trust them to make the right calls here because they just have so much Are we
You
okay?
keep going.
Okay, cool, sure. And then some for the back.
Yeah, I was curious, you were talking about unanswerable questions in VizWiz dataset. When you were rolling out 4.0 to your blind users, did you do anything specifically to prompt the user to change the frame or fix the image if there was some sort of video or degradation?
I don't think we did anything specific actually, no, we did. In the system prompt, we actually said only respond if you're like 99% confident. And if not, call human. So like Be My Eyes, our partner for rollout, actually has a system to call a human. And they basically were like, if the model is confident, then proceed. If not, you know, call a human. And that actually seemed to work really well, which is how we learned like there were so many failure cases. Yeah.
And this is a game you can play with a video setup too, right? Like it's like it kind of sucks if you're like, gets back to UX. So sorry, I'm like beating the dead horse. Like you're in the text mode, you take a screenshot, you upload it, you press the button, you upload it, you like add a little caption, and then or ask the question, and it's like, I can't do anything with that picture. Can you send another one? You're like, crap. It takes another minute. But like with video, it's like, oh, could you zoom in? Sure, I'll just move a little closer. Right. So it's that fluidity, I think, really matters.
Let's do.
Sorry, yeah.
Just curious, where day-to-day life, do you spend more time on data or model 50-50?
I don't think I've done research in a year. But so neither.
I'd say 75.
That's a good answer.
So, once again, you have mentioned the importance of data and how to determine the data, quality of data. How do you know whether this data are usable or not?
That's a difficult question because like I think we always say inspect your data set. And like, you know, sometimes you find examples that are like obviously wrong. But a lot of the times you find things that you think are wrong, but like don't matter. Somehow the model just learns through the noise. So honestly, I don't know. Like, I think if there's very obvious like mismappings, yeah, fix that. But beyond that, as Ilya once said, the models just want to learn. Just throw all the data in. I don't know, but like downweight it maybe. I don't know. Yeah. All the way in the back.
Like the VLD users might have different demands of the from the regular public efficient person. I just wonder when you turn like whether you fine tune the model or you change the system prompt to adjust for the VLD.
I don't think we like adjusted the system prompt based on the users. Like ultimately, like there's so many tasks that to adjust the system prompt, we still just use like, okay, take like a benchmark of 40 capability evals and 40 safety evals and see what works best. We have to look at it in aggregate because otherwise we sort of end up playing into our own biases if we look at specific examples. Although we still do that to understand refusal style. For the blind users, we sort of do it at a system level. We make sure the whole system works just as well for them as others. And yeah, I think that's it.
Yeah, sure.
Yeah. So you mentioned a lot of challenges like reduce the hallucinations and improving safety. So among all of these challenges, which part do you think is the most challenging one, or like to further improve the capability of people?
Sorry, can you repeat the question?
I mean, like which part do you think is most challenging to further improve the capability of people?
I actually think the most difficult thing here is, as Rome was mentioning, UX drives capabilities, capability drives UX, capabilities drive UX. And you have like this cycle. So you end up in a place where you're constantly going back and forth between like deployment, design work, and training data on any given week. And you know, at that point, neither of them are hard. You kind of just like surfing between all of them and you sort of have to ride the chaos. And like,
there's no real clear delineation between whose responsibility should be what at a certain point. You sort of have to just like own all the parts and like figure out how to pull them together. So I would actually say the most important part to spend time on is the part in between and figuring out how to connect these different components.
Project management.
Yeah, honestly, yeah, you have to be your own PM, pretty much.
You ever see these models? They're all, they're like extremely large. And maybe not a phone, but maybe like processing like a Mac or something.
As I think like without commenting on like specific technology, I think as a meta point, you have to like look at the trajectory of our technology. Like, you know, we're sort of like at, you know, the 90s for this technology, right? Relative to phone technology. And we already want it to be on a phone. We've just gotten so used to the design paradigm for a phone and edge devices. Back in the 90s, they wouldn't even have thought you could put it on an edge device like this. So if you realize that like, oh, it took us like 30 years to get just the last generation technology on device and it's capable, like, I think that, you know, it's super, super possible that these technologies will eventually be on device one day. And at that point, hopefully then we'll have even more powerful technology that's just like in the cloud instead, because that's sort of the design paradigm you saw like over the 90s. Like you had to do sign and cosign in the cloud in the past because it was too expensive for your local computer. But now, like, I mean,
Did they even have the cloud back then? I don't know.
the IBM.
Yeah, no, I get you. Yeah. No, capabilities UX, right? Yeah, boom. Oh, we're probably over. Yeah, go ahead.
So, E4O, a video model on the image model. So I say that I think it's a video model, but in my time, will just behave like a image model. So I'm curious about doing the video model.
Yeah, it's GPT-4o image or video. Well, I think that
It's the same thing.
what?
Those are technically the same thing.
Yeah. I think, I mean, I think that I think that's right. And also, I guess for context, the version that I demoed is not the it's like not quite out yet because we need to land the safety and like inference speed and all these other really important things.
Yeah.
So.
Due to time constraint, we're not able to take more questions, but thank you again, Raul and Rowan from OpenAI.
To get out of the house. Yeah.
Right, so now we are proceeding to the next session.
Yeah. No.
So this year we accepted 11 extended abstracts, and we're very happy to have 7 authors today to present as posters. So now let's welcome these 7 posters. By the way, you are able to view their papers on our website. So yes, let's welcome our poster authors.
Hey, hello everyone. I'm Sang-Won Lee from KNU Hanover team. Let me walk you through our proposed method. First, we use LoRa for efficient model training and fine-tune the cross-attention model. Second, we utilize the query-aware segmentation feature from a ClipSeg model. Lastly, we employ an ensemble of various predicted results to improve accuracy. In our experimental results, we find that integrating segment feature information directly into the model is more effective than other method. Thank you for listening my presentation.
Now let's have the rest of our poster authors line up right here. The next poster presentation is leveraging large vision language models for visual question answering in business.
Hello, everyone. So on behalf of my team, I would like to present our approach for the challenge. So our approach is based on prompting various large vision models to output the answers in a suitable formats for the challenge. And the figure here is the example of the interaction with the models. And so we use some guided prompts to leverage the capabilities of the vision language model. We try various models here, and each model is fine-tuned on the datasets using parameter using fine-tuning techniques such as LoRa and DORA. And we find that LoRa achieve the best result without ensembling. And finally, we ensemble 33 models to choose the most frequent outputs, favoring the better performing models. And we achieved an overall score of 76 on the 20 data sets. Yeah. Thank you.
Third is visual question answering with multimodal learning for VizWiz VQA. Do we have E1 here? If not, let's proceed to the next poster. Use of altered visual enhancements or global elements.
Hello, everyone. My name is Yuvanshu Agarwal, and I'm here to present to you Shifted Reality, navigating altered visual inputs using multimodal LLMs. If you've ever heard of Be My Eyes, then you know it's widely used by the blind and visually impaired community in order to navigate their surroundings. And they've recently released this new feature called Be My AI, which essentially allows users to click photos, upload these images, ask questions, and receive GPT-4V generated responses. Now, from the previous presenters, we know that these images are not always of the best quality. And so this research is an empirical study in order to understand the limitations of GPT-4V when being presented with such types of images. And so we've used questions as well as images from the VizWiz dataset. And from our research, we've found some interesting conclusions, which is that when presented with rotated images as well as some cropped images, GPT-4V can produce hallucinations. And ultimately, I think this is sparking a greater question as to the dependability as well as the safety of GPT-4V when used by the blind and visually impaired community. Thank you.
Thank you. Now let's have our next author, Mega Whisperer, making comics accessible to everyone.
I just want to preface that this is not how this spotlight's supposed to look like. But we'll roll with it again. Hi, I'm Raghav. I am a PhD student at Oxford, working with Andrew Zisserman. And in this 1 minute, all I'm going to do is introduce the problem, and hopefully in the last 10 seconds, I can convince you that you should also work on it. The idea is that we want to make comic books accessible to visually impaired individuals, right? In this particular work, we are limiting the scope of the problem to generating like a dialogue transcript. So you can imagine taking a page like this, like a single page, and we want to go from there, like a single RGB image, to what's being said, who is saying it, and what order is this being said in, right? I'm not going to talk about how we do it. You'll have to come to the poster session either after this or Thursday morning. But more broadly, you can imagine taking this as like a visual abstraction of reality. So you can imagine these panels are key frames of a video. And can we go beyond this to really describe what's happening to a visually impaired user, right? And it's really challenging because you can have characters that look different depending on how the artist wants to render them, or you can have characters that are visible for different viewpoints. And how do you capture that? How do you capture intent, which is not a continuous video, right? So let's chat more if you're interested. Thank you.
Now let's have our next based informer for recognizing visual questions with multiple answer them.
Yes. So hello everyone. So today I would like to present our research. So I think that this data set is very helpful for the assistive technology to help people to recognize the object based on the input image and the question. So basically the problem here is even we have the same question and same input image, the result may be shared a different segmentation mask. So our solution is we spread into the two agent. The first agent is try to recognize the potential answer, and from that, the second model try to recognize the segmentation mask, and from that we can know if this share the same coding or not. And I think this workshop and this data set BQI terabyte is very helpful for developing the assistive technology. Thank you.
Thank you. Now let's welcome our last poster spotlight.
Good morning, everybody. My name is Zuo Jianglong, come from Huazhong University of Science and Technology in China, guided by Professor Gao Changxing. I feel very glad to have the chance to present our work on the challenge of zero-shot image classification. In this work, we propose a simple but effective pipeline for the zero-shot image classification, which explores to utilize the extraordinary understandability of large multimodal models via a cross-modal validation method. The method is mainly consists of three parts. The first is proposed with volume, and the second is match via Nava and Kimi, and the third is voted by multiple experts. By combining these three parts, we can achieve effective zero-shot image classification. That's all. Thank you.
Thank you all for the great previews of our posters. So our next session, starting right now, is the poster session. And if you are interested in these works, you are encouraged to go to Arch Building Exhibit Hall to talk a little bit more about these works with our authors. Thank you. Our next session will start here at 10:30.
And if you don't know what it is, we will be doing 2 waves. So Tommy is going to head over
All right, who's excited?
Me.
Yay!
Woo.
Our engaging audience. So now we are back. Let's move on to our next session, which is the overview of the rest of our challenges. So this year we have in total 3 challenges that are related to either few-shot learning or zero-shot learning. So both of these technologies are growing more and more useful and impactful to the blind assistive technologies in the past couple of years. And we are very excited to host 2 new challenges in these areas this year. So as a quick introduction, fusion learning allows the models to learn from very few new samples and then gain more knowledge from them. So with this strong learning ability, it allows the models to build more personalized and customized applications for our assistive technologies. And for zero-shot learning, it actually does not require any more samples in the use cases. So there is no extra teaching, which allows these models to be able to apply to very diverse domains. So the first few shot challenge this year is Orbit dataset from Microsoft. This is a video object recognition dataset collected by 67 blind and low vision people, including 3,822 videos and over 400 objects. So this is actually the 3rd year that we're hosting this challenge. In the past 2 years, we are seeing very fast growth and accuracy. So we are very excited to hit this milestone that we can move on from just considering accuracy to considering both accuracy and computational efficiency. And this means that in the future, we will be able to apply these algorithms to more lightweight deployments, such as cell phones. And the next future challenge this year we have is VizWiz dataset. This is a private object localization dataset collected by 26 blind and low vision people, including 1,028 images with 16 different private categories. This is the first year that we're hosting it, and we're getting 4 entries this year. We can already see the progress from the baseline is huge. And last, our zero-shot challenge is the VizWiz classification dataset. This is a zero-shot object recognition challenge with over 8,900 images, covering 200 object categories from ImageNet. And this is also the first year we're hosting it, and we're already getting 24 entries. So the exciting part, we are announcing the winners. This year, the Orbit Challenge winner is Team Eco AI. They achieved frame accuracy at 71.67. And I think we have this team online, so let's have them take over.
I cannot share my presentation. Please. Yes, let's begin. Could you hear my voice? Can you hear me?
Yes, we can hear you. Please start.
Okay. Hello everyone. Thank you for joining us today. We are the Echo AI team, and we will be discussing our work on distributed mobile VIT for the VizWiz Future Challenge. Let me introduce our method. We developed an efficient and accurate lightweight fusion model by combining three key components for this challenge. These three key components are Vision Transform architecture, automated data augmentation, and a knowledge distribution framework for the future object recognition task. In the beta training stage, we first apply automatic data augmentation to the support set. Then knowledge distribution transfer knowledge from the powerful teacher to our complex student model. During the test, we use only the complex student model to perform personalization. On this slide, we explain the details of network architecture. In video object analysis, the VIT module has demonstrated outstanding performance, so we aimed to incorporate it into our approach. Then recent work has explored investigating vision transform into mobile-friendly architectures as shown in below table. Among these architectures, Mobile S2 was identified as the most proper backbone for our future object recognition task. The second key component is the data augmentation. The best combinations of augmentation rendered an exhaustive search is feasible during the challenge period. Therefore, we investigated the recent automatic augmentation policies. Based on our evaluation results, trivial auto augment was found the most robust performance gain for our future object recognition task. For the knowledge distribution framework, our large teacher model was evaluated, including VIT, Clip, and Dino V2. Then Dino V2, a large model for vision task, was identified as the most proper teacher model for our future object recognition task. To address the model capacity gap between the large Dino V2 teacher and our compact mobile S2 student model, we incorporated a normalization of the logic during the distillation process. For the experimental result, we compared our mobile S2 model against the baseline method. The VITB Clip baseline has a high accuracy but is penalized due to high computational cost. The efficiently V0 is more efficient but has a low accuracy. Combining trivial augmentation with the enhanced knowledge distribution framework further improved the accuracy to 71%. In conclusion, by effectively combining the three techniques, our method achieved an improved accuracy on the future challenge while maintaining a low computational cost. Looking ahead to future work, we aim to extend this research by developing practical solutions to effectively detect or identify image waste material within eco-friendly industries. Thank you for your attention.
Thank you, Team Eco AI. Our next challenge is the private objects localization, and the winner is Tela AI team. They achieved the bounding box map score at 58.84 and segmentation map at 58.41. And now let's hear their presentations.
We are working on few-shot object detection and location tasks. We introduce the methods we use. Overall framework. For each category, we use only one sample. First, we augment the images and then train the grounding Dino model for object detection. Simultaneously, we utilize the annotated bounding boxes to extract the target regions for training the EVA-CLIP model. During inference, we perform object detection using the grounding Dino model. The detected object regions are cropped and input to the EVA-CLIP image classification model for categorization. After image classification, we further identify specific categories related to text. For this, we primarily rely on the llama adapter model. Other categories are directly considered as the final output. Combining the results from the above steps gives us our object detection outcome. Finally, we integrate the object detection results into the segment anything model to obtain the final instance segmentation results. Object detection module. We perform data augmentation on the images, including adjustments like light, motion blur, flip, rotation, perspective, and hue saturation changes. The augmented data is used for training the model. Note that the annotations need to be adjusted accordingly after data augmentation. The training process involves freezing the backbone network and fine-tuning the model by adding an adapter former module in the text image fusion part. Refining object categories. Although the object regions are roughly localized after the object detection module, the specific categories may not be accurate. To address this, we introduce the EVA-CLIP model. For each category, we use only one sample and fine-tune the model after image augmentation. The trained EVA-CLIP model corrects the detection results by refining the bounding boxes. These refined boxes are then input to the fine-tuned EVA-CLIP model for classification. Despite these efforts, the recognition of text-related results remains less accurate. Therefore, we incorporate the LLAMA adapter V2 model, which performs text recognition on text-related images and optimizes the category recognition based on keywords to determine the final detection results. Finally, we combine the detection results with the segment anything model to obtain the ultimate instance segmentation results. Final evaluation. Our final evaluation scores are as follows. Mean average precision, 0.5884. Average precision at IOU, 0.5, 0.5647 for object detection. Mean average precision map, 0.5841. AP at 50, 0.5574 for segmentation. We introduce a method for one-shot object detection using open vocabulary detection. Additionally, we leverage multimodal large models such as EVA-CLIP and Llama Adapter V2 to accurately classify target categories. In the future, for one-shot or few-shot tasks, we will attempt to fuse the image features of one-shot samples with its corresponding text features in our object detection model to improve the recognition ability of these samples. We found that fine-tuned open vocabulary detection algorithms can locate the position of targets, but category prediction is not accurate enough. Pure image-based algorithms struggle with solving challenging examples from daily life, such as distinguishing between business cards and credit cards, or books and notebooks. To address this, introducing additional semantic features becomes necessary. Existing multimodal large-scale models can work well in semantic feature learning. However, we still need to fine-tune those models to enhance its recognition performance for some less common objects.
Thank you, Team Tele AIA. It seems like we are not sharing screen on Zoom, so please allow 1 second. All right. Back to the last announcement. Our winner for this year's zero shot image classification is Team HB New. They achieved the accuracy score at 67.69. Now let's hear their presentation.
Hello, we are Team HBNE and we will be presenting on defining shadow labels for robust test time adaptation. Method consists of the teacher and student models. The teacher model outputs shadow labels using augmentation averaged shadow labels. The student model incorporates a progressive by 3 convolution layer alongside the principal block and exclusively claim the 3 by 3 convolution layer. To provide more accurate shadow labels to the student model, we introduced two methods. First, we examine all shadow labels within a designed range of epoch, and if any inconsistencies are detected within this range, they are excluded. Second, we adopt shadow label uncertainty estimation. Specifically, shadow labels with low entropy are considered to be more reliable. However, inaccurate shadow labels still exist. To prevent the model from overly relying on incorrect shadow label interpretation, we adopt diversity regularization. Additionally, since we use the model pre-trained on VizNet, it makes prediction for unnecessary clashes. The prediction is designed to calculate the loss only for those corresponding to the classes present in dataset. Thus, the method mentioned above we obtain more accurate shadow labels and reduce the influence of inaccurate labels even if they are used. Therefore, we can utilize the price contrast law guided by accurate shadow labels. When utilizing shadow labels, performance increased by 6.25%. Applying the shadow labeling scheme resulted in an accuracy increase of 0.3%, with an additional 0.2% improvement achieved the diversity regularization. Furthermore, integrating class masking led to a notable performance enhancement of 0.45%. Finally, employing the provided contrast growth led to a performance increase of 0.15%. Our main ideas are the 3 by 3 convolution layer and the shadow labeling scheme. The source of our idea are indicated in the notation. By adding the 3 by 3 convolution layer, we aim to run out of distribution inspired by the approach introduced in the reference paper to handle the unseen noise. The shadow labeling scheme draws inspiration from the annotation, where the best shadow label are observed to form negative pair for contrastive loss calculation. The following graph compares the performance of previous method by varying the pre-trained models. As can be seen, the performance ranking changes significantly depending on the pre-trained model used. In the future, test time adaptation methods should be robust, regardless of the pre-trained model they are applied to. Thank you for listening.
Thank you, Team HB New. Congratulations to all the winners again, and that is all for our challenges this year. So next, we are going to have our next invited speaker, Brian Fischler. Brian is a stand-up comedian. He is a writer and also a podcaster. He's known for his podcast, That Real Blind Tech Show, which they discuss the assistive technologies for blind and visually impaired. And he is also the founder and the producer of Laugh or Sight Benefit, which raises money for retinal eye disease research and guide dog programs. And today, Brian is going to bring us his talk, Will Computer Vision and AI Revolutionize the Web for People Who Are Blind? Let's welcome Brian.
Okay. Push the link. There you go. Hey, how's everybody doing today? Thanks so much for coming out. It's Wesley, my better half here. So thank you so much for that nice intro. And I've been a professional stand-up comedian for 20 years and funny for 2 of them. So but unfortunately, I'm not here to be funny today, because today I'm here to talk about the state of computer vision and AI for people with disabilities. So, you know, there's no laughing to AI unless we're going to talk about the hallucinations. So to understand kind of my story, you kind of have to go back to the beginning. I grew up sighted. I went totally blind in 2009. You know, it was tough. You know, I lost my last full-time job. I lost my apartment in Midtown Manhattan, and I ended up in Jamaica, and that's not the good Jamaica. That's Jamaica, Queens. Yeah, when you're used to living in Midtown Manhattan, when you walk out your front door and everything's there, to go to a place like Jamaica, Queens, it's pretty tough. You know, it changes your entire life and what you're used to. And I ended up in a dark room staring at a wall saying, well, what am I going to do with my life now? I had not really ever used technology. I didn't grow up with technology in my life. You know, back when I was a kid, the only people using technology were nerds. And I'm now thankful that the nerds have won, because I now rely on all their technology pretty much to do everything. And this was all about 2011, that I was in that dark room looking at the wall, thinking about what am I going to do with the rest of my life. And I think back then to 2009, where I went to the Lighthouse Guild in New York City. And there was this guy from this fruit company, and he had this iPhone 3GS. And he was flicking around the screen, and it was talking to you. At the time, as my vision was failing, I had been using a BlackBerry, but I couldn't see the screen anymore. So I immediately got that iPhone 3GS, and I learned how to use VoiceOver on it, the talking screen reader. So flash forward back to that dark room in 2011. I had never used a screen reader at the time. I had always used magnification when I needed it, inverted colors, that sort of thing. And I ended up getting a Mac with VoiceOver, which is their screen reader. But the problem was nobody in the country was teaching anybody how to use it. I mean, even at the Apple store, they sold me Windows for Mac, and I spent about a week trying to figure out how it worked with VoiceOver, only to find out that in 2011, VoiceOver and Microsoft were not playing very nice together, and it didn't work with VoiceOver at all. And the people at Apple didn't even know that. So anyway, I'm in that dark room, and thankfully I connected globally with other blind people that were learning how to use VoiceOver, people in Australia, people in Europe, and we kind of became our own community where we bounced questions off each other, and we learned how to use that screen reader. And it got to the point where I became such an expert with VoiceOver that I ended up designing the curriculum that New York State Commission for the Blind still uses to teach other blind people how to use VoiceOver. They probably should update it by now, because that was a long time ago that I designed it. And I think this kind of all led to, I believe it was 2012, the VizWiz challenge. And this was the first time that we in the blindness community got our hands on any kind of image recognition. And it was revolutionary at the time, but it was based on crowdsourcing, which was really slow. And you depended on, well, who knows if that person that's answering what this object isn't a complete lunatic. You know, you were really dependent on them. I remember sometimes you would take a photo and it would take 2 days to get a result. You know, before any of this though, yeah, you'd order your groceries as a blind person, they'd arrive, and let's just say you shouldn't order anything that came in the same size together because we had no clue what it was. So say you ordered toothpaste and hemorrhoid cream, well, that could lead to a really uncomfortable situation. Okay, so I brushed my teeth once with hemorrhoid cream. That was enough, but yeah, so then the VizWiz challenge came out, and this was the first time where you could order toothpaste and hemorrhoid cream in the same and take a photo of that box and get an answer, sometimes in 2 days. But this was the way things were going, and you know, it was really fascinating at the time. And you know, the VizWiz challenge then kind of led to some other apps coming out. Seeing AI, as well as Envision AI. And you know, my personal favorite for taking documents, which is called Voice Stream Reader. Not sure about why they renamed it to VD Scan, by the way. I don't think they had a marketing department at that company. That's what it's called nowadays. But you know, these were the first apps that they were allowing blind people to get rid of those old school bulky scanners. I mean, that's how blind people read their mail. You put it in a scanner and, you know, it took time, it was clunky, and the results always weren't the greatest, but documents, anything, you know, there was no way for blind people, anytime you got a credit card in the mail, you know, there was no way to get that scanned back in 2012, 2013, until some of these apps came along. And then with 2015, it gave us the apps Be My Eyes, as well as Ira. For those of you not familiar with them, they're voice interpretation services. And actually, I was kind of stunned when I was looking at this, the one that Be My Eyes made it out first. Be My Eyes is an app that uses, I guess, crowdsourcing, where a person that's blind could call a sighted volunteer and have them help them find the door to a place they're looking for, or scan some mail, or anything they need help seeing. You know, what's this product in my hand? That sort of thing. And this was another step forward. And then the great thing about IRA is it's a more bonded service that you pay for, so you weren't relying on the kindness of volunteers to find information. You know, for example, your tax documents, you don't exactly want to be scanning that with complete strangers. And the great thing about IRA is they were able to manipulate the camera and zoom in. So they could take that perfect photo of my tax documents since I started paying them and, you know, pass that along to my accountant and everything, making life much more simple. You know, they could also take a photo of my guide dog doing something cute that I wanted to capture, you know, because when these apps came out, you know, blind people taking photos, it was still a little clunky, you know, talking about images, you know, as well, going back to 2010, you know, when a blind person looked at an image on a computer, it would read to us IMG dash 8675309, you know, well, that might be a catchy song. It's not very useful information about the photo. And then, you know, around 2013-ish, 14-ish, Facebook started telling us maybe a photo of a dog, you know, which that was kind of cool, you know, but it wasn't too descriptive. You know, flash forward to nowadays using services that have evolved, such as Seeing AI, which really came out in 2017. And Seeing AI, it's coined the Swiss Army knife of apps for blind people because it does so many things. It does short text in real time. For example, I order food service and I like to I'm eating, believe it or not, they have labels on it. I just take it out and within seconds, it's telling me what that item is and everything with unbelievable accuracy. It's also a document scanner, a currency reader. I could snap a photo of it of the people in this room and get a scene description through Seeing AI. And that's why it's known as the Swiss Army knife, because it does so many different things and it's still evolving. You know, and now we got to the point where we eventually got to the explosion of AI and how AI and computer vision has massively improved the lives of people with disabilities. Be My Eyes has become Be My AI, which I've been very fortunate where I was an early beta tester. And now we're getting to the point where I could take a photo of boxes of soda and not even have to ask the question, and it'll just automatically tell me what it is. I am now to the point, you know, we used to have the days with these old apps where you could take a photo of a menu and it would very slowly read you the entire menu. Now, say I know I want a sandwich. I take the photo of the menu with Be My AI and say, just tell me about the sandwiches. And it's much faster. And people that I'm eating with, it doesn't take me 3 hours to read the menu. That's appreciative of that. And you know, now you have other apps that are jumping into the AI, as Ira too has now got their own AI and taking photos. There's an app that we just had on my show, that Real Blind Tech Show. Yes, shameless plug. PixieBot. And this is a developer that way back in 2012, he's Dutch, created an app called Googly Eyes, I think, pardon me, it was something I'm blanking on, it doesn't exist anymore. Talking Goggles, pardon me, that was the name of the app, Talking Goggles. And this was another one of those apps that would scan products and help blind people read them. Well, his new app, PixieBot, it's the first app that I know of that it's describing video to blind people, where if you take a 30-second video, it'll tell you what's in that video. It'll tell you if somebody's narrating, the tone of the person narrating's voice. And this is how rapidly everything's been expanding as far as native and mobile apps go. The problem's been screen reader technology, where we've gotten updates here and there, but it has not exploded as rapidly as these apps have. I mean, I remember a time where I became quite proficient, obviously, as I mentioned, with voiceover. And I spent a good hour navigating a shopping site for dog food and dog toys. I won't mention the name of the company. And I finally got to the end, and I was very proud of myself, finding everything I needed. And I go to do what Control Option Spacebar to click the checkout button, and nothing happens. I click it again, nothing happens. I click enter, nothing happens. And you know, this is still the state of web accessibility, where people are not designing for people with disabilities. I was just at another conference and I met people that are grad students and PhD students at some of the top programs in design in this country. And I said, hey, I'm kind of curious, how much of your curriculum included screen readers? 0. How much included inclusive design? 0.1, maybe. All that they were taught about was color contrast, and that's the problem. The designers are not being given the proper tools and not being educated about inclusive design and screen reader accessibility. And believe it or not, people with disabilities use the web. We just went through a few years ago the greatest example in human history on why websites need to be accessible, the pandemic. If you lived alone and had a disability, how the hell were you going to shop? How the hell were you going to do anything? And it's amazing. A lot of companies get it, but there are still a lot of companies that don't get it. They think it's going to be too expensive to properly code their website. They try to use a cheap plugin, which ends up making their website even more inaccessible in a lot of ways. I could go off on hours to the plugin companies, and it is baffling. And then you get small designers that are just so committed to accessibility because they get it. It's good business practice. You're going to make more money. It's proven fact that people with disabilities are returning customers more than people without disabilities because we become committed to companies that go the extra mile. There's so many companies that have fought accessibilities, major companies, Amazon, Spectrum Cable. And those are two companies that once they got into accessibility and creating accessible design have become two of the biggest. Did I get cut off?
Yeah, been happening intermittently.
I was like, what is this, the Oscars? My time up? Anyway, the companies, I'm not bad mouthing Amazon or Spectrum. They've become two of the biggest leaders in accessible design and commitment to accessible design. There we go. And it's just education is really the focal point. And I now, 75% of American blind individuals are unemployed. That's a baffling number. Of the 25% that are gainfully employed, I was talking to a colleague of mine, and we anticipated that as little as 1 to 3% of the 25% employed are actually employed at corporations, meaning that 22% of blind employed people are either working for a state agency or working for a blindness specific organization. I'm fortunate enough where I just went back to corporate America. I'm not here speaking on their behalf today, but I'm now working with Yahoo. And that's a company that is so committed to accessible and inclusive design. And the reason I bring the company up in the work, as a lot of you probably work with Figma files. And even though Figma claims their files are accessible, they're not accessible. I'm looking forward to a day where I think we could be a year away with computer vision and AI, that when I look at a Figma file, I'm calling it personal AI. That's where I wanted to get to, where this AI is going to know that I'm blind. So I'm not going to have to tell it every time, remember, I'm blind, so I can't see this, blah, blah, blah. It's going to know, it's going to be smart enough to know that. And it's going to tell me when I'm looking at that Figma file, here's the design, here's the spacing, the things that I never thought I'd be able to do. My colleagues are fantastic because they know I have limitations, but I'm looking forward to a day where those limitations are gone. And I think computer vision and AI is getting us there. The day where when I encounter an inaccessible button, because the web, it's never going to fully be fixed. People have spent years doing lawsuit after lawsuit, suing inaccessible websites. And you know what we find out? They pay the fee, the lawyers get rich, and then they never end up fixing the website because people just don't. Unfortunately, people don't care. That's the problem. The people in this room, they care, but unfortunately, all the people making the decisions don't care. So with computer vision and AI, I think we're getting to a point when I encounter an inaccessible button, I'll be able to tell it where to click and it'll do it for me. And this is where we are now. This is where we're getting to. And it's just going to be making people with mobility issues and everything. We never thought that they'd be able to use the web in the way that they're able to use it today. And it's all because of what's going on in the rapid speed of computer vision and AI. Unfortunately, when it comes to hiring, we're still going to have to depend on people until AI can replace the hiring managers. But I think it's a spectacular time. And I think it's only going to get better. And, you hear all the negativity out there about AI. This is the positivity about AI and what it's doing and the amazing things that people with disabilities that can't see, they're able to do now. And I think it's pretty cool. And I'm proud to be a part of this community and can't wait to see what people in this room and other people come up with next. And I guess any questions or anything, I'd shout them out because I can't see your hand.
Can you list a few problems that still exist in your daily life that perhaps people in this room could help or people at this conference could help with?
Yeah, AI, not everybody's beautiful, so, oh, it's a beautiful person. No, it's funny, there's a lot of generalizations when using, people description and, yeah, I think, obviously we've all heard about Apple Intelligence and what they're doing and, to be able to look through photos and know that that's my mom or that's my guide dog Wesley, this was my previous guide dog Nash. For it to be able to differentiate between people, I mean, as somebody that was able to see up until 2009, photos when we were at, IMG, whatever, that was useless. Maybe photo of a dog, useless, really, somebody that was able to see. But now the descriptions are getting so just brilliant and descriptive that I'm actually back into taking photos. I'm actually wearing the Meta Ray-Bans, which I can take photos of. And so I think that being able to get more intelligent and tell photos who is who, that sort of thing, would be pretty cool. And, just continuing the speed of it, real-time video. That's where I think the AI in the future is gonna be, not even having to snap that photo, to be able to put something on a wearable. I mean, the blindness community, it's so funny because people are like, blind people wear glasses? Yes, we do. And everybody wants everything in a wearable. And the day that like the wearable could just take real time, okay, for example, I used Ira to walk over here from the hotel today. I called the sighted volunteer, they gave me great directions and it's fantastic, but I look at a time where the glasses, which are open ear and bone conducting, so I can hear what's going on with around me, will tell me, okay, make a right, make a left, and it'll be using computer vision to help me navigate. I'm still gonna have to walk around with a guide dog or a white cane, obviously, but to be able to get that in real time, that would be spectacular. Yeah.
Even though the casting is getting amazing, I still feel like it would be helpful to be able to interrogate the document about images, because it may not tell you the specific thing that you're interested in. Right. So I'm just curious if that, what you think about that.
Follow-up questions, that's obviously gonna be important. That's what we can do now. So having the ability to get the description, but then being able to ask that follow-up question and it knowing or being able to tell me that. So I think that's important. It's obviously nobody, some people might, and this is the thing with screen readers as well. Some people might want a shorter description, other people are gonna want a longer description. You're never gonna make everybody happy. But to have that opportunity to get the information and then to ask follow-up questions about the data that's been captured, that's what's pretty cool as well. And I know we can do that in a lot of places now. Pi is another app that I know that I'm using a lot, that it's pretty cool. That you just ask questions. It's not taking any photos per se to give you data. But yeah, it's the follow-up questions with photos, I think is probably very important. And I know with Be My AI right now and Ira AI, you could ask follow-up questions to the photos that it's captured. Cool.
Brian, I have a question. You mentioned screen readers to access websites and how interactive the websites are. Moving forward, a lot of the trends seem to be around fixed reality, AR, VR. Do you have any suggestions on how we could be, have inclusive accessibility like first class citizens when we're designing those things and what that would look like? If you have any thoughts on that?
That was just at XR Access and all about virtual reality accessibility. And that's a tough field. It was interesting. It was really fascinating. Seeing some of the projects that people are working on. And the thing with VR, AR is there was one project that, you were able to move around in a space and get spatial information. But with the explosion of AI now, I'm like, okay, well, this was really cool 10 years ago, but now we're getting close to being able to do this in real time in the real world. And I think just spatially, manipulating that to the real world is kind of where the future of VR is going to be. I know you got to create a lot of that in an environment for testing and safety purposes, but I think real world practicality is kind of the best design for that moving forward, at least in my opinion. And that is a subject that goes way above my head, by the way. That's some pretty cool stuff.
Brian, I have a question for you about personal identification. So wondering what you think about the ability, like we can identify people. And you could use that with the Ray-Bans now, but there are obviously a lot of reasons why companies are worried about government too. And I'm curious about how you think about that balance and how you think we ought to talk about.
It's a very, very interesting question. Very good point. Yeah, there's a lot of privacy. For example, when Be My AI first introduced the photo feature, where it was scanning photos, we went through a period where it would automatically say face blurred out for privacy concerns. I think this was, they're partnered with ChatGPT. And, honestly, if you're going to want to use this stuff, personally, I'd put up on privacy. That was the thing of the 20th century. It's all gone. But I get, you're going to be walking down the street. Part of me is like, people recognize that these are the Ray-Ban Meta glasses. And is somebody going to walk up and rip them off my face because they think I'm taking a photo of them? I mean, that's a situation I don't want to be in. Other people's privacy, where they don't have a disability, they don't like all this stuff. It's a very tricky situation, and it's a tough crossroad to be at. From a company perspective, I think I don't know what the answer is. I mean, you don't want government getting involved, definitely, because we know they can only screw things up tech wise. But are you going to allow these companies? I mean, Facebook and their history of giving everybody's information away. But when it comes to somebody like myself, blindness, I said, the hell, I don't care about Facebook's history of giving away everybody's information. They'll be able to ask these glasses and say, hey, META, what am I looking at? And to get an answer most of the time that's right, it's worth it for me to sacrifice that privacy. But the fully able people, I don't know what the answer is, because they don't need the technology that I need. So I think, for somebody with disabilities, if you want to use the products, you're going to have to sacrifice the privacy, unfortunately.
When we available, Voice Omni and Vision, Be My Eyes app or ChatGPT app.
What was that?
I think there's a question that's being asked virtually and a question that.
Oh, okay, yeah. So, yeah, what was the question in the room was about the different app, that there was a problem with the Meta glasses. I heard that part.
The comparison of your usage of wearable technologies and your phone. And then because I heard from people with the blind or low vision, when using the phone, it takes much more time and adjust right angle to aim the right thing, and also they want to have something direct face to the thing they are actually facing. So I just want to hear from your experience of your.
Yeah. Now, I have never been a big photo taker. I've just started doing it recently since I got these glasses. And with the phone, it does tell you, iPhone and Android, point left, point right, and I could never seem to, get it to tell me if I'm pointing in the right direction. Honestly, like I said, most of the times before I got these glasses, if I wanted to get a photo that I knew was good, that I wanted to share to social media, I'd call Ira, have the agent take control of my camera, take a photo of the dog or friends or whatever. And, that was my go-to. But since I got these glasses, I am taking photos, but I'm still asking a sighted person, hey, is this a good photo? And so far, every time they've said yes. I think the advantage of the glasses is that it's holding still and taking the photo, where, with the phone, you still really don't know. So I think the wearable is probably going to be the future for people snapping photos that are blind. I hope that answered your question.
All right, so we're able to take one virtual question. If you have a question, you can just unmute yourself and shout out. Thank you again.
Great.
All right, thanks so much, Ryan, for that awesome talk. Next up, we have Elissa Price from UCLA. Elissa is an assistant professor at UCLA, where she directs the Koalas Lab. Previously, Elissa received her PhD from Stanford, where she worked on unifying tools from NLP, psycholinguistics, HCI to investigate communication context for language use. Most recently, her work is centered around automatically generating image descriptions, which I learned are very different from captions. So hopefully she'll tell us about that. And yeah, without further ado, I'll hand it off to her to tell us about how communicative principles should shape human-centered AI for non-visual accessibility. Also, ask her about bananas.
Thank you. Okay. All right, thank you for the generous introduction. I'm very delighted to be here today. So in my talk today, I would like to take a step back and focus our attention on the way that we define and evaluate what we commonly refer to as the image captioning task. And specifically, I will show evidence that in order to build systems that seamlessly integrate with real-world user needs, we need to start treating tasks like this as communicative problems. The image captioning task, as we know it today, originated from the challenge of simplistic semantic concept matching. That is, matching the image of a dog with the concept dog. So fundamentally, this task is about saying things that are correct about an image. Put differently, we can conceptualize the origins of image description generation as aiming to solve the question, what can we say about an image? But with the emergence of very sophisticated and prolific vision language models, we now need to move this task to the fundamental pragmatic question of what should we say about an image? So what does that mean? So here's an example of the, yeah.
You just put on that.
Yeah, I think I can.
I apologize.
No, that's all good. I just cannot see the mouse. I think it's left. Maybe we have to do this for a second. There it is. No. Okay. Thank you, thank you, thank you. Technology is your friend. There we go. All right. Is this good now? Great. So here's an example of the sophisticated image-based text that today's models can generate. So GPT-4V provided the following description for an image showing Barack Obama, namely, a man in a suit gestures while speaking with the US flag in the background. But crucially, there are many texts that could plausibly go with every individual image. Other truthful descriptions of the image are Barack Obama giving his last State of the Union address, or also a hand with an index finger pointing up, seemingly attached to a person who has their mouth open, teeth are visible. All correct. And this one-to-many mapping and the challenges that come with it is going to be the main focus of today's talk. Because choices on what to say and how to say it have significant consequences for when these models are put with real people into accessibility scenarios. And today I will present recent work that shows how useful image description generation needs to be shaped by two fundamental communicative goals: the communicative goal of the text itself and the communicative goal of the image. And in the first case, I will show how the task definition in generating accessibility descriptions hasn't previously been well defined and start addressing this disconnect with a new data set. And in the second case, we worked with blind and low vision participants as well as sighted participants to show that image description generation can't be treated as simply an image to text problem, but actually requires a more holistic view on the situational context. So let's start with the first one and what I mean by an image-based text communicative goal, because it's sort of a mouthful. So let me take this image showing an educational sketch of a plant, explaining the various parts that make up this plant. And let's say we have encountered this image in the Wikipedia article on multimodal pedagogy, which is an approach to teaching that implements different modes of communication, including visual and linguistic. Now let's create, there we go. Now let's create an accessibility description for this image. Bring some dynamic movement into the talk. Okay, so maybe something like this. An educational sketch of a plant illustrating the shoot system, which is above the soil, and the root system, which is below the soil. The different parts of the plant are labeled to point out, for example, the plant's reproductive shoot, that is the flower, or the lateral roots. So this is one image-based text. But there's actually a second image-based text on this slide, and basically all images on Wikipedia have it. And it's the text below the image. So that's here, example of complementing linguistic and visual information leading to learning benefits over unimodal approaches. In journalism jargon and library sciences, this is commonly called a caption. And the other image-based text is commonly called a description or visual description of the image. Now, both of these texts are indeed image-based texts, but they have very distinct communicative goals. Descriptions need to replace an image and therefore list all the relevant aspects of an image. Captions presuppose that the person already has access to the image content, and the caption simply complements that information with details like how the image relates to the broader context, who painted that picture, when was the image taken, etc. And importantly, one cannot play the role of the other, and only descriptions are really suitable for serving an accessibility goal. However, in AI, we're still largely treating all of these texts the same, often without considering how these tasks are fundamentally different. And in fact, it all falls under the same umbrella term of image captioning, the task of generating some linguistic text that is based on an image. So we're not currently choosing our data models and evaluations based on the distinct purposes the texts intend to achieve. So the hypothesis is that they are fundamentally different image-based texts, and if we don't pay attention to this distinction, resulting models will be misaligned with accessibility needs. So let's investigate this. So to investigate this distinction, we've introduced a Wikipedia-based dataset called Concadia, which contains images and their corresponding captions, as well as accessibility descriptions that were written by Wikipedia editors. And a first important thing to note when we are discussing the description caption distinction in Wikipedia is their distinction in distribution. So based on 10,000 randomly sampled English language articles, we estimate that about 90% of images have associated captions, but only 6% have an associated alt text. And those 6% still include low quality descriptions that simply consist of the image's file name or are non-English language. So the true coverage of actually useful alt text in English language Wikipedia is therefore much lower than 6%. Is this me? No. Okay. I hope you're awake. And this further dramatically highlights the accessibility challenge on the example of Wikipedia. So, but aside from this clear difference in distribution, how do captions and descriptions actually differ semantically? So here's one example from the Wikipedia article on bananas. Shout out to bananas. The caption that appears below the image reads, "Cavendish bananas are the main commercial banana cultivars sold in the world market." And the accessibility description for the image reads, "Grocery store photo of several bunches of bananas." So clearly, the caption would be inappropriate as an accessibility description, and reversely, the description would make an incredibly unhelpful caption. So this reflects some of the expected patterns, but does this actually scale up over the whole data set? In a suite of large-scale analyses based on the naturalistic data, we find very strong evidence that the content of alt descriptions and captions differs in structured ways. For instance, captions most frequently mention events and names like World War, San Francisco. But descriptions talk most frequently about image aesthetics, like color photograph, black and white photograph, or descriptive features like dark hair, mustache, etc. Now, what does that mean for potential accessibility models that we train on this data? Do trained models actually differ in how descriptive their generated outputs? So we investigated the description caption effect on 3 different models, 2 LSTM-based models with attention mechanism, and a transformer model, which today still has competitive performance on most image-based text generation tasks. And each model was trained twice. Bless you. Once on the caption data from Arcadia, and once on the description data from Arcadia. Now, how do they do? So here in each plot, I'm showing the performance of the respective model on description generation on the left and on caption generation on the right. And a higher CIDR score indicates that the texts generated by the models are closer to the original texts from the dataset. So let's look at the results. So across architectures, we found that caption generation, which is here in orange, is significantly more challenging than description generation, which is here in green. And intuitively, this makes sense, because an accessibility description is much more grounded and anchored in the image, since it's meant to replace it. A caption, on the other hand, will contextualize it with, for instance, the year that the picture was taken, which is way less extractable in and of itself. And both tasks therefore pose their own distinct challenges for model development. So until this point, we first established that the content of descriptions and captions differs in structured ways. And now we found that this actually affects how models learn these tasks. But is this actually a distinction that is connected to the text's communicative goal? And secondly, should we expect this to affect the type of models, the type of text that models generate? To investigate these questions, we conducted a pre-registered human subject experiment. And in this experiment, we took images from our dataset and displayed them next to a sample text. So this could be a description or a caption associated with the image, and either the ones from the dataset, so what people actually wrote, or the ones generated by models. So each image was randomly paired up with one of these associated texts, and then we asked 2 questions. The first one is getting at the text's descriptive quality. So how useful would the text alone be to help someone imagine the picture? And the second one is getting at the quality to contextualize and provide non-redundant information. So how much did you learn from the text that you couldn't learn from the image? And the results are very encouraging for our hypothesis. We find that human-written descriptions from Concadia, which are presented here in green, are considered more useful for imagining the picture than captions, here in orange. On the other hand, people learn more from captions than they do from accessibility descriptions. So now the captions, again here in orange, get the highest ratings. So this is strong support that captions and accessibility descriptions actively optimize for different communicative goals. And this is actually important for models as well. When we show participants the texts generated by the models, the results pattern exactly like the human ratings do, suggesting that models are picking up the nature of this distinction, and it actually affects their downstream performance. So the results from all these analyses, the large data analysis, the model learning analysis, and the controlled human subject experiment, they all suggest that the communicative goal of our utterance changes the information that becomes useful. And it therefore has to become a central component in dataset generation, model development, and evaluation as well. So now we have explored how a distinction in the text's communicative goal changes utterance content and the suitability for functioning a priori as accessibility descriptions. But attention to the text alone, a text goal alone will not suffice. And this is where we come to the second challenge that I will focus on today, namely the image's communicative goal, which matters too. And for that, allow me to introduce you to a theoretical framework for conversation analysis and linguistics called the Gricean maxims. Who's heard of the Gricean maxims before? Okay, great. So a lot of people learn new things. That's exciting. So Paul Grice put together a set of conversational maxims that we seem to implicitly rely on when we're making communicative choices. And it's probably the most general framework that is used in linguistics to analyze how people interpret rich conversational meaning. One maxim is that we expect others to be truthful and that they have evidence for what they say. But for our purposes, I would like to emphasize the maxim of quantity. The maxim of quantity states, make your contribution as informative as is required for the current purposes of the exchange, and do not make your contribution more informative than is required.
Alexa then?
Yeah. And here's how this might play out in conversation. So to the question, how far is it still to the bathroom? One could respond, not far, it's across the hallway, turn left, and then 3 doors down. Or one could say, not far. Now, context, or the current purposes of the exchange, mitigates what is appropriate. So in the contextual scenario where I need directions from a stranger, the long and detailed response is appropriate. And in the contextual scenario where a child really needs to use the bathroom and we're already hurrying towards it, the short response is absolutely sufficient. So there are always infinitely many details we could include, but context makes us choose which ones. And I believe this is what's commonly reflected in much recent work, primarily in human-computer interaction, that calls for moving away from a one-size-fits-all approach to non-visual accessibility. So let's explore how this contextual principle similarly applies in visually grounded interactions. And let's return to our motivating example with the images, visual description, and education sketch of a plant illustrating the shoot system, etc. And that's embedded in a Wikipedia article, excuse me, on multimodal pedagogy. So here the purpose of the image is to exemplify complementing visual and linguistic information in one figure to aid learning. And the visual description nicely communicates that. However, the same image could similarly appear in a Wikipedia article on plant anatomy. So here, the purpose of the picture is to enable the reader to learn and understand what the different parts of the plant are called and how I can identify them. So now this previous description seems highly insufficient. Imagine that I am a student using this Wikipedia page to practice for an exam. Then this description won't allow me to learn what I need to learn. So instead, I need an image description more like this. A sketch of a plant illustrating the shoot system, which is above the soil, the root system, which is below the soil. Part of the root system are the tap roots and the lateral roots. The tap root refers to the central root, and the lateral roots are the smaller side roots, that, etc., etc. So mentioning the labels now becomes absolutely essential if this text is intended to replace the image and still enable the same communicative function. In the previous article on multimodal pedagogy, listing all of the labels and how they relate to the plant would be distracting. It would be overbearing. It would just be not useful. So the informational selection is fundamentally guided by the communicative goals of the image in that particular context. Currently, image description generation is largely treated as a context-independent problem. The data follows generally a structure where each data point simply consists of a picture and an associated image-based text. And these could be obtained by crawling the web or giving the pictures to people and ask them to describe. Most task-specific models follow the structure we discussed before, where a model receives an image as input and then returns some text. And even for models that can take more complex contextual input, this often remains underexplored since the task itself generally is defined as context-free. And when it comes to the evaluation of generated descriptions, the images and the text are given to a person or a scoring model, which then returns an evaluative score. So in my view, the research area of interest needs to move towards investigating contextual integration into the development pipeline, which is also my personal focus. And the data effort you've actually already seen in this talk. Our Wikipedia-based data set Caucadia contains very rich contextual information where the image appears. For example, the title of the Wikipedia page and also the closest appearing paragraph to the image. So now that we have the data, we can actually investigate models that can integrate that richer data. So when we investigate how models do when they have access to contextual information during training, it's a very clear picture. Overall, we can recognize the pattern from earlier that description generation seems largely more successful than caption generation across conditions. Providing an image's context during training in the form of either a closely occurring paragraph or the corresponding caption or description improves performance throughout model architectures. And providing models with an unrelated context paragraph during training doesn't lead to performance improvements, suggesting that the improvements for all model architectures that are due to the content of are actually due to the content of the context and not just additional linguistic input. So these brief results are a first indication for the value that context awareness can add to goal-oriented image description generation tasks. So now I spend most of this talk and most of my time on how we can make models better, be it through better data or changes to the information that they receive to generate image descriptions. However, there's another very crucial component for model development, which is actually the evaluation of those models. And I will talk about this important aspect for the rest of it. So the problem of model evaluation in simplest terms is the following. If I have two models that differ in some way, how do I know that model 1 is better or worse than model 2? And there are different ways in which you can evaluate whether a model is improving. The most straightforward way is probably asking people. So participants will be recruited and they have to judge, are these image descriptions good or not good? So for the first one, they might say, yay, this is great. And for the second one, no, this is very bad. And then I do this over many examples, and then I can say holistically, model 2 is judged as performing worse compared to model. And if done well, that's a big if done well, this is incredibly effective. However, it's also costly and it takes a long time. So for that reason, evaluation by human subjects is usually just performed when we're basically done developing the model. It's not feasible to do that whenever we make a small tweak, slightly change the data, etc. So we have to rely on other metrics that we hope approximate people's ratings to a reasonable degree. And a new popular way of doing this is the following. Suppose you have a very powerful model, which has learned to associate text with images and the way that they occur online. Now, wouldn't it be just great if we could just give the model an image and a description, and then it would just tell us how good it is? And this is the general logic of so-called reference-less metrics. And ClipScore is the most promising one of those. It's already being widely adopted in model development, with multiple papers arguing that ClipScore has the best alignment with human ratings compared to all alternatives. However, there's actually no straightforward way of integrating the context the image is in into the evaluation pipeline. In our work, we specifically wanted to put this to the test. How much does context matter in practice? So first, we created a data set where we explicitly focus on the case where images are part of a larger context. For instance, we took an image of a church and then placed it in a variety of Wikipedia articles, like building material, or Christian cross, or roof. And we then recruited sighted participants on Amazon's Mechanical Turk and presented them with these contextualized images and asked them to write a description that would make it accessible to blind and low vision users. So now we have descriptions that are actually written for images appearing in broader contexts. And those descriptions were then evaluated by sighted as well as blind and low vision users. To facilitate a better understanding of what constitutes a good image description in context, we chose a multidimensional evaluation framework based on pragmatic principles of communication. I can say more about that later. And sighted participants answered this set of questions twice, once before and once after the image was revealed to them. and blind and low vision or BLV participants answered the questions once and then proceeded to answer a set of open-ended quality questions, which I'm happy to talk more about later. So before we move to comparing the human ratings with CLIP score, let me first take a brief moment, to compare the data we got from the sighted participants here on the y-axis and the BLV participants here on the x-axis. Overall, we see good correlations across questions between both participant groups at about 0.5 to 0.6. But I want to zoom into two additional findings here. First, we find that hiding the image from sighted participants does not improve their alignment with BLV participants. Instead, we see that correspondence increases when sighted users actually can see the image. And secondly, we also identify a scenario where the ratings from BLV participants and sighted participants come apart. The ratings of sighted participants remain unchanged, independent of description length. However, the BLV participants in our sample show a very strong preference for longer over-shoulder descriptions, really highlighting the importance of direct work with BLV users for system design. Now let's move back to the main question. Can contextless metrics like CLIP score be used to guide the development of AI systems for accessibility? So for each description, we have ratings from people for how good it is and a rating from CLIP score. And if CLIP score is a useful evaluation metric, we should see a good correlation, which might look something like this. This. So as the CLIP score ratings increase, the human ratings should increase. All right, now to the results. We actually found that CLIP score ratings show no correlation with human ratings data. And that's true for both sighted as well as blind and low vision participants. So as soon as we enable people to judge a description within a context an image appeared in, the correlation with CLIP score vanished. Now, since CLIP, the vision and language model that CLIP score is based on, there have been an unspeakable number of new and improved vision language models. So in a recent study, we investigated the general promise of using them as proxies for human participants. We tested a wide range of current state-of-the-art vision language models and first correlated them with ratings from participants on a new naturalistic data set we collected. And across the board, the Pearson correlations with human ratings are high. So simply based on correlation evidence, we might consider this a success. However, we show that actually all models have categorical and non-human-like biases in their score assignment. We introduced 10 data augmentations that should necessarily lower the assigned score of the description and find that none of the tested models actually passes them all. For instance, consider this image description, a dog with big ears, and let's suppose a model had given it a good rating. Simply repeating the description twice, as in a dog with big ears, a dog with big ears, results in a much higher assigned score than without the repetition. And similarly, simply adding elephants are the largest existing land animals after any description tends to improve the assigned score. So this work really highlights that artificial agents are still not appropriate replacements for human evaluation, however sophisticated they might currently seem for generation. So in sum, saying something about an image seems easy, but choosing the right things to say is highly complex and depends on many pragmatic and social factors. And this requires highly interdisciplinary efforts of fields like computer science, human-computer interaction, linguistics, psychology, communication, and many more, which can lead us to novel insights about multimodal communication and automatic generation systems for non-visual accessibility that can seamlessly integrate with user needs. So thank you very much for having me, and I'm looking forward to the questions on the panel, which I think is the next thing on the agenda. Thank you.
Thank you, Alyssa. So let's go ahead with questions while we get the panel there. So
sounds good.
Eric.
Sorry, I have a question.
Oh, wait.
Okay, can we go to the online question after this one audience question?
Yes.
Great. Okay, then let's do that. I'll come back to you. I won't forget you.
So I guess, so I think a lot about designing the output of generative AI.
Mhm.
And I think what you talked about is, one way of thinking about it is essentially that. So if you kind of know what the communicative intent that you're trying to achieve, you can better do that. But what I thought was interesting is toward the end, you said something about, but getting kind of humans involved in, I don't think you used the word design, but I might use the word design,
Mhm.
is expensive and it takes a lot of effort and
Mm.
whatever else. And so we may have to do this automated thing. Whereas I might argue that there's no free lunch. And actually, we have to do the hard thing. And I wonder what you think about that.
Oh, I absolutely agree. I never meant to argue. I should clarify this. I never meant to argue that this is a matter of replacement. It's not a matter of replacement. I do think that humans and users who are actually affected need to be a central part of that pipeline. It is a reality that we need intermediate goalposts in between. And I think that's an important parallel effort to make those intermediate goalposts that we can use for quick system evaluation instead of, the important ones that are significant milestones that have to integrate people, but we need those individual ones in between as well. They also need to properly represent people. They're not a replacement, but we need them as intermediate steps for model development on the fly. And I think in that sense, it's a very important thing to be thinking about. Does that address your question?
Yeah.
Okay. Can I take the question that was over Zoom? Okay. Do you want to ask the question again over Zoom?
Great question.
Yes.
So
Do you want to ask it? Yeah.
when we
Go ahead.
when we available for ChatGPT Voice Omni and Be My Eyes app or ChatGPT app.
I think we lost you. Maybe you can write it in the chat, and it seems like that would be a great question also for our panel, where we have more experts on that as well. So yeah, please write it in the chat, and then we can address it in the panel.
Go ahead.
Yeah.
So I know in the language test, they are using a reward modeling of the preference, but in this is just a clip score, and most of the VLM, they don't use like reward modeling trend or fine tune. So is it possible to maybe train a reward model based on the image and text and replace it using as their evaluation solutions?
Yeah, I think that would be very interesting to evaluate. I mean, currently it's also a question how you're then getting the score out of the model. And we find that actually the strongest biases don't come from the models themselves, but actually from the way that you're extracting the score. So in the paper that I discussed here very briefly, we specifically compared similarity-based metrics, so where you actually work on the representation space that the model learned itself, versus you work with the log likelihood to get the score based on the probability of getting the generated description based on the image, the context, and condition that it's a good description. We find that the method of extraction is actually way more important and influential than the model training specifics in the first place. So I think there's a lot of work that's still needed on actually extracting the scoring method as well, but I'm happy to talk about that. But I definitely think model learning approach is also an important matter that needs further research there.
I think that at this point, we'll switch to panel questions. Switch to panel session, so we can have all the invited speakers kind of sit down.
And feel free to reach out to me if you want to talk more. Thank you.
All right, well, take a seat, take a seat. All right, so this is going to be fun. So I'm Jeff Bigham. I'm going to be moderating this amazing panel. So I just want to say quickly, so before you is this amazing set of speakers. I don't know if everyone got to see and hear from everyone, but what I really like about the VizWiz workshop is how we bring together such an interesting set of folks who are all kind of thinking about using computer vision for accessibility. And so now we get to ask them a bunch of interesting, hard questions at the intersection of their skill set and experience. So we're going to try to do that. Okay. But first, just quick kind of rapid fire. I'm hoping just go down the panel. And we'll pick on Lisa here. We'll start with you. So the other people have a little bit more time to think.
Hi.
What's like one takeaway that you have from this workshop so far? Perhaps thinking about, the people that spoke outside of your expertise or not. What's like one takeaway? Lisa, pick on you.
There are a lot of, should we have a mic or is it good?
There are mics, but they're all kind of, here, do you want to, here, you can hold that.
I can project, but
You can hold that.
it might be. All right. Hi, everyone. I think, first of all, I will probably lie in bed tonight and think of, oh, this was a way better answer than what I gave. But the first thing that for me comes to mind is that I saw a lot of opportunities for us to talk more across disciplines. And I think this workshop is a really great opportunity for facilitating that. And we should have more of those opportunities, be it academia talking to industry, but also being experts in computer vision and NLP and HCI and the social sciences talking to each other. Because I definitely learned a lot about different perspectives, and I don't want to pick up one particular thing, but just the interdisciplinary exchange is something we could really do better. And yeah, I'm grateful for that.
Awesome. All right, next up. Rapid fire.
Last one to this. Well, one thing for sure is intent. I guess we should go fast. Yeah.
Yeah. Okay.
Yeah, intent. Like just try to understand what the users actually want. Also on cross-disciplinarity.
Oh, super fast.
I think that it's the most it's like to see interested in this topic. Like, a year ago, like I had no experience or expertise working in this. Didn't really know what I was doing, and I didn't know that there were this many other people interested in working on this problem. And I think like accessibility is still not ideal on the web. Like it's like all like shopping on the web where it's just like features sounds like insane. So there's still so many problems, and it's basically so many people you're interested in technology maturing that like kind of hopeful that we'll all sort of figure it out, because I think we've come a long way in keeping your making things that are possible. So yeah.
Mine would be excitement. I guess we're at a very exciting time for computer vision and AI. It's going to be very fascinating to see where all this will be a year from now, because things are happening so rapidly. So excited for this.
All right, keep the mic, Brian. I gotta. Or did you want to follow? Anybody can. So keep the mic, because I want to turn this to a lot of speakers mentioned this kind of concept of safety, which I think is sort of this, umbrella term. It can mean a lot of different things. But Brian, I remember in your talk in particular, I thought you mentioned two examples, which I think were interesting kind of contrasts. You mentioned like the toothpaste and the hemorrhoid creams, like, oh, that sounds like a safety issue. But then you said, why can't the thing just describe the people in front of me without telling me everyone's beautiful? And so I was wondering if you have thoughts on like, how do we move forward with this? Because I think it's a fundamental challenge generally across the field. And then when you think about technologies for people who are blind, I think that there's kind of a different dimension, which different people touched on. So I'll let you maybe start, and then want to hear from some of the others.
I think, there's no one correct solution for everybody with this. I mean, everybody's different, like I mentioned before. It even goes down to verbosity with screen readers. Some people want more, some none, all, it's such an individual choice that I think AI is gonna be the same thing as the dog gets curious. He's like, don't replace me with a robot dog. But I think you're just gonna have to present people with as many options as possible. Because, I mean, that's just with consumers as well, you know, nobody ever seems to want the same thing. Description for somebody, some people, like I said, some want more, some want less, and I think just giving people as many possible options to choose from would probably satisfy the most amount of people.
Anybody want to follow up? Any other speakers? Yeah. Go ahead.
Oh, go ahead. I think one of the other things we're seeing with RLA chat, like giving people what they want, I mean, is you're optimizing for human preferences. Like, I think like a lot of the times, like, if I have like a wall of OCR, I don't want all of the text, like I'm just getting about it. Or like if the model is using a tool, like I don't need you to generate the whole Google search, just like give me the gist. And that's what I would want. And through this process of like alignment, I'm hopeful that like over the coming years, we'll actually be able to like, you know, go beyond like rule-based or like sort of like handcrafted solutions and like actually instill what people want into the behavior that into the behavior of these systems. How does like hold the line between like safety and policy and getting the masses what they want though? That's like a separate moral question. I don't have answers for it. Yeah. Yeah.
Anyone else have comments? No, it's like the hardest problem right now. You're all. Okay. So I guess another thing actually that Brian mentioned, it was this push toward these plugins, these overlays that try to automatically fix accessibility in web pages. They don't live up to the promise right now. I was wondering, I mean, anyone who has maybe comments on this, but I think it's a general challenge when the promise or kind of the way we talk about the technology kind of puts it in the most positive light, and maybe it's not there yet. And we have thoughts on like maybe from the industry perspective or lived perspective, or how do we ramp up responsibly when the technology doesn't quite do everything we want, while still recognizing there's huge potential. It's time for it's a safe room to pontificate.
I mean, I think where a lot of these overlay companies got it wrong was nothing about us without us, where they didn't even, I'm thinking of one in particular, they didn't even consult with any blind screen reader users to build their product. So I think that's why they got it wrong. And, could these overlays have possibly have been something had they been properly designed and done in the right way? And can computer vision and AI potentially eventually do that? I think so. I think if the parameters are set right, and again, the customization options, I think it comes down because, even with screen readers and more low vision, I mean, why is a low vision toolbar completely acceptable, but these plugins for screen readers aren't? And I think it's because they were so poorly designed and the results and that sort of thing. But if AI and computer vision is going to give people customization options, I think that could definitely be very promising.
Anybody have thoughts on that?
I'm hesitant speaking up because I feel that's not my area of expertise, similarly to the privacy question, but I'm going to use my turn to hopefully correctly quote someone else. Chancey Fleet was making a wonderful point just a couple of days ago at a different workshop about how these technologies are a wonderful opportunity because they make things accessible that previously weren't, but how the same technology can then reduce the effort brought in by people to make accessible solutions themselves, like writing alt text for your images. And connecting back to the notions of intent, you, the person who took the picture and uploaded it, are the one who knows best what to take away from that image in most of the cases. And so you're going to be the expert for writing that alt text, which an AI can sort of approximate, but can probably never meet because not even another person would probably really understand why you posted the pictures and what you want someone to take away from it. So sort of trying to keep the focus on parallel efforts as opposed to replacing the human component is, I think that was something I took away from the other workshop that I thought was very helpful.
That question, Donna?
Should we take some questions?
Oh yeah, let's take a.
Yeah, so I was wondering, in some of the work while I was at Yahoo, we used to do is allow users to have apps and randomly during the day ask, hey, what are you doing? Like, so it was like, and they were given some money. So here, maybe provide apps to this particular group of people with low vision or whatever and say, okay, what difficulty did you have today? And so that would create a sort of focus of issues that they feel during the day and how important this pain was. I don't know whether Brian people would do this, participate in such a thing. They did this, I think the paper was from Telefonica or something in Spain. They did the study, and so it was very useful, and we used it to sort of analyze what we should work on. Sort of prioritize. There's really things you can work on. So how do we prioritize? Otherwise, we are solving a problem that doesn't exist, kind of a thing. So, wonder whether anything like that has been done for this company.
For which company, I'm sorry?
So has anybody done a survey sort of providing, so it looks like not, where low vision people have this app where they can say what problem they are having and goes into a common corpus such that later on we can analyze it and work on.
I know with a lot of the apps, assuming you're talking about AI, that there is a lot of beta testing going on. I don't know if they've specifically broken it down to low vision users versus, no vision users. I've not been asked. I've been involved with a lot of the betas, but I've not been asked. I don't know if they just know that I'm totally blind and have no usable vision. But they should be testing for low vision. I mean, that's low vision, unfortunately gets left out a lot of the time, and that's kind of, it gets taken for granted because I think low vision is so much harder to create for, because what is one person's low vision, what they could see compared to somebody else with low vision, it's so individualistic that I think it is tougher to design for low vision in mind. But I know that there's a lot going on with color contrast and fonts and stuff like that as well.
I just to add, I mean, there is a huge body of work in accessibility, understanding what challenges that people who are blind using a bunch of different methodologies. So you're trying to describing experience sampling. But there's a whole bunch of methodologies that have been used. I think what's interesting as the technology has matured, first with sort of crowdsourcing and then now with machine learning, AI, you can actually get the technology out into people's hands so that it's not sort of this artificial, hey, what problem do you have like right now? But like you can start to kind of get them to say, here's the problem I'm having, and I'm trying to use this app to solve it. But certainly good instincts of let's make sure it's real problems we're solving, and relying on the literature too, because I think there are experts out there. I mean, both, yeah. Anyway.
Because actually that's sort of like what I was alluding to at the end of my talk, like I felt like we really needed this, like while developing our apps at OpenAI, and like, we just sort of had to like run into all the problems ourselves. If this exists, then maybe this is actually, a problem of like, not having the right cross-disciplinary like pollination, because like then we all agree that like, this is a super like interdisciplinary workshop where we like to get into. So I guess we're supposed to be answering questions, but like I do wonder how we can do this, because like I would like it honestly, like it would make like my life a lot easier. I think make a lot of our lives a lot easier. Those things, man.
We have a question from the chat. So Doreen asks, how generalizable are these models? And I kind of want to like build off of that and be like, does your definition of generalizability change kind of after today? Like, what does it mean to be generalizable in the context of people with like varied abilities?
I'm sorry. I think that's a great question. I want to put in my slogan here, which is, I talked about context a lot, and context is context specific. And that includes the needs of the users and who is approaching the system, and coming back also to Brian's point of always having to say again, oh, I'm a blind user, I might have these preferences, etc. So there's definitely a call and demand, and I think also a theoretical motivation to build systems that have personalized components that go with my expertise. When I'm a hairdresser, I need hair explained in a very different way than when a system explains hairstyles to me, who has no clue about hairstyles. And similarly, my age will affect my demographics, my cultural background. And all of those things are under explored, but they clearly demand for personalized solutions. And how we can facilitate those, again, coming also back to Ryan talking about identifying my mother, my job, etc. All of that is the personalized perspective, like generalized capabilities in general for visual extraction, language complexity, but we still need personalized adaptation to serve user needs in communicative situations.
Yes. I have similar thoughts. I guess, there will be components that are generalizable. Syntax understanding, for example, this kind of like common occurrence, right? You want these kind of capabilities embedded, probably. Please correct me, but things like one thing like as I go through with this, for example, things that I didn't realize, like color recognition or spatial understanding, right? That would be components that are generalizable, but I do agree with the sentiment that in the end, personalization.
I think it's actually even more like extreme than personalization. Like, taking a step back, like at the meta level, like what matters is like that you're able to understand a piece of information and do what you ideally want to do with that information. Everything else is like an interface helping you get to that point and go on after that point. So like there's for user personalization, but like with multimodality, and like just all the different, like say like images on a web page or style of a web page, whatever. There's a plethora of ways to like organize a particular piece of information. So you actually need not just like personalization to a user level, because some people understand things better through certain media. You also actually need like personalization based on the data itself. Like, I mean, this is why, it's agonized so much over like formatting our papers, right? Or like creating like, educational material for kids, right? Like just presenting those bits, organizing those photons in those particular ways, like just for some people, like help you clock it. Like, there'll be like times when you're trying to understand a concept for like days now, and somebody shifts the explanation and it just makes sense. And with our current tech, like, and the way we design like interfaces, it's like, you know, one website for everyone, for every web page on the website. But I think as we like now have these tools with multimodal systems and like systems that can not only see but write code, we hopefully will get to the point where like the user, the design and the interface that you see is like changing on like a data point like on basis, like yeah. Yeah.
Talking from a testing back, I think it's so great. So many companies now I know are specifically testing customers with disabilities, which is great. The issue is because of the closed nature of it, that none of the companies are sharing the data that they're collecting because of proprietary stuff and lots of other things. So it's really a company by company basis to what they're learning and what we're doing, you know, besides what people share at conferences like this. And you know, I don't know if there's ever a way, you know, we know how companies are, if they're going to open it to everybody, but and then also the thing with when testing for people with disabilities is you've got to really try and test for the average user. You know, somebody like me who's an expert with most of these things is going to experience it a lot different than using these products and sort of things. I remember recently I went to I can't remember the website, nor should I probably say it. And it was an accessible, and I'm like, huh, never seen that before. And I'm like, yeah. But I'm supposed to be the funny one. But no, it's so still companies are introducing new web accessibility barriers on almost a daily basis. And I don't know, well, hopefully we'll be able to get past this, you know, in the next several years.
I've been curious about this for a long time. How do you treat disability representation in these multimodal models that are coming up? So I'm basing this out of a research that was conducted by one of my fellow PhD students at UW, where they basically just looked at disability representation, and it was mostly like people with wheelchairs, and they were disregarding other types of disabilities. And similarly, like if you give a prompt in a text to image generation model that show me a face of a disabled person, it usually comes up with like gloomy face or sad faces. And I think partly this is because of the training data. I think there's lack of misrepresentation or like misrepresentation there. But again, because of the privacy and safety concerns, these type of data sets are not freely available. And it's very, again, expensive to just use the real users to get the data. So what are your thoughts how to actually increase the representation of different disabilities, but also disabilities with multiple identities, like a disabled person with race associated?
I know, if I'm understanding correctly, you know, and that's something where the inclusive design comes in, and it's going to be very company by company specific, but considering, you know, people of all different backgrounds, especially marginalized communities, and it's just trying to gather as many I guess data sets that you can test for. And I know that's something that we try and do, and that a lot of other companies are trying to do to expand upon, you know, just bringing in, for sake of example, 5 white 40-ish males. You know, you want to kind of get somebody from all different backgrounds, because they're obviously going to experience what they're told, whether it's from computer vision or AI, much differently than I would do it. So I think it's just trying to get as wide of array of testers as possible as the best possible practice.
Because we haven't mentioned the term yet, human-computer interaction is a great search term to look for research that has thought about this for quite a long time and has been studying these questions and a lot of detail thinking about the complex interactions between identity and disability as well. So I think that will be a useful resource for a lot of people to look into.
I have a very practical answer here. But sorry, but go ahead if you want to answer first. I think I would answer one. So the very practical answer is, from a research and capability standpoint, like you always have to trade off one capability for another thing. So for people to include, accessibility on data models, like, the numbers still have to go, right? For everything that's well. That's like a very boring thing. Like it's pretty easy to make that happen. More practical answer is like people usually want to do the thing, but people don't know how. People don't even know where to get the data. I don't even know where to get the data. Like I did some things for it. And everyone is just busy. Everyone's just tired. I mean, like, okay, it's still a startup technically. I mean, like our research staff is like pretty small. And like we want to be the most, but it's just hard. And everyone has their own other things that they want to focus on. Their own goals, own dreams, desires, wishes, whatever. So a very practical perspective from like working in a big organization and like getting people to change what they're doing to work on your thing. You have to make it easy for them. Like you have to honestly do like 90% of the work and take on to other people's burdens, right? Listen to them. What are they dealing with? How can we make their life easier so they have time to do your shit? And like, I think that's it, like going to all the different companies, all the different parties, taking on like whatever, hearing all their concerns about why they can or can't navigate politics. It's a very, very important practical answer. And that stuff takes so much more than you think. Like, I mean, with everyone, but like, you just need to be a champion and sort of believe in it and make that your thing and just be willing to put in the work over like a long period of time and find the right, doors to knock on and stuff like that. And that is hard, but the doors probably exist somewhere.
Can I use a moderator's prerogative a little bit? And I also jump in. I have a simpler answer. Make it non-negotiable, right? You can't do that necessarily in every position, but some companies do. And so, for instance, Apple will not ship something that doesn't work for people with disabilities. It just doesn't happen. And not every company is at that point yet. And that's the hard work. And that's the hard work that we're also talking about. But I think that's the actual answer. Make it a value that the company sees as non-negotiable.
Non-negotiable.
It doesn't have to be easy. It can be hard, Well, easier is easier, but you got to be non-negotiable even when it's hard. And I'm not saying this for any particular, I've worked at lots of companies, right? So it's hard to change the culture, what the company values, but ultimately that's what works.
And I think like maybe the way I see it is maybe I think y'all are like Jeff, you and Raul are talking about two different things, I guess, in terms of and your question is also about another thing, I guess, in terms of like I think, for I will not shipping anything that like doesn't do right by people with disabilities, that's like talking about a core output of the model. Whereas if we're talking about what kind of training data that goes in, that's kind of an intermediate component, right? Of course, maybe it manifests in possibly biased outputs. Maybe that's due to other problems in the model. Maybe it's due, like, you know what I mean? And so there's kind of a lot of levers you can pull here, some of which are politically more easily you're able to pull than others. I think that's maybe summarizing Raul's point. So yeah, I think all these things are important. And like the concrete thing, like if you're in academia, it's like making evaluations that really measure exactly what kind of output you want to see in, say, text to image models. And then we can track those and be like, okay, it has to be above 70% or whatever on this evaluation or ship model.
Yeah.
Follow-up question for collecting data that align with the blind and low vision users. for this part, like your model, we need to have a good data, and with good data to align with blind low vision users, we need probably a large amount of human annotators. Even to train a model, we probably need tens of K or 100K of data to be good. How to overcome this amount of data? Like in order to train the model or either fine-tune or RLHF or some other way, we need a large amount of data, but like even to recruit blind and low vision user. But they are quite different from the what's vision people see, and the need or ratings might be different. So how to overcome to have enough human annotators to label the data or to, especially for alignment with the blind and low vision users. Are there any possible directions or ways to start with this?
Be sassy first, but it's a very like CDPR take, like hiding the soda, trying to like push soda numbers and ImageNet farther. You know, you need like bajillion data points. You know, when you start actually like working with these larger language models, I'm hoping like the entire community gets to start working with them soon. The sample complexity, the amount of data points you need to like do well on a problem, drops dramatically when you fine tune it. We've seen this with like BERT, making like new tasks solvable finally for the first time. But with these models, like and RLHF and supervised fine tuning, like honestly, most of the time, like you can get 60% of the way with like 100 data points. And if you realize that all of this data is exponential, or has like you need exponential amounts of data to provide more value, you know. Sure, 20,000 versus 30,000 data points is good. Nothing for the model, but it's going to be really exhausting to gather. However, 100 to 200 data points is going to provide a lot of value. So, you know, there's two problems. It's like, okay, you got to scale up your data collection, but you need to figure out what to scale first in the first place, you know. And for that, honestly, you can do it with like 100 data points. Like the age-old, like sort of adage of like, oh, go gather your lab mates and have a pizza party and label some data over the weekend, actually kind of works again. Like, and we have done that for so many of like, you know, the safety modifications that we did were that, you know, like, okay, someone gave us feedback. Let's just sit down with an Excel spreadsheet for like all Thursday or something like that. And then you get to the, you know, 1,000 data point mark, you're like, okay, this is really working well. Like, let's go get like all the data annotators. We figured out like problems with data annotation, and then you go and gather those. But you can get so far with like just like 100, 200 data points and that crafting.
But I think you're also getting at a really interesting question, which is, what are the interesting data points and how can we best leverage recruiting from a low incidence population? And I think this is an area of research that we need more work on, which is explicitly comparing where we get the most informative and important data points from the blind and low vision participant community. And this means understanding in detail how the experience between a blind and low vision user differs from the experience from a sighted user. That also means understanding the nuances in the blind and low vision community in experience. Like, for instance, there's well-documented differences in experience when you have been blind since birth versus acquired blindness later on, which is in addition to like the distinction between blind and low vision. So we're actually seeing that in studies right now that we're doing in my lab on the accessibility of data visualizations, where color information becomes differently relevant, etc. And so specifically those pieces of information need to be oversampled then when you are in a sort of data restricted scenario. So I think this is actually a very exciting domain for further research.
It is a survey paper for in different fields that would be very nice because it can help us. I think some people already know it. The other people who are from other areas are not aware of the literature. So
And I think like I kind of echoing these points, I think it's like I feel like this is like what is it? This is a call to action to make a different type of data set than what has often been made in the past, right? Where we put a lot of thought and care into relatively fewer examples rather than kind of like go for quantity rather than quality, I guess, which feels like kind of weird that like I'm up here talking about this, given that like, LLMs are trained on so much data, but like there's kind of two regimes and they're very different from one another in terms of how you want to teach your model to behave at the end of the day, and then how do you train the best base model. And because these are different regimes, we can use very different tools. And yeah, no, I mean, it's just like, maybe that's how we can start studying these questions on, say, personalization, right? Making it such that the answer is not just conditioned on like a short question, but a history of a user interaction in long context. Like so many possibilities when we look closer at each data point that I wasn't able to do during my PhD because the technology was there yet.
Sounds like VizWiz 25 is.
Hey. So maybe one last, so what we're supposed to be, probably like 40 minutes ago, we're supposed to be done, right? Yeah. Yeah. So Nisa, you had your hand up. I'm gonna pick on Nisa way back in the back. Did you want to ask a question?
So I was wondering, I think connect to customization, personalization context. A lot of those, the source is the actual user. And so the promise of AI was that it's going to take this burden from the airporting here, from the society to have to do things accessible, and AI will take over it. And I'm wondering whether are we pushing this burden on the hands of the blind community? Right, they will have to provide the content, they will have to do personalization, they will have to do personalization. Now, is it just a shift of the burden, or are we actually really hoping that AI will actually pick over that part too, and will automatically, magically understand the content that the user needs, understand the specific customization or personalization? Just, I was wondering, right, your thoughts on that. But
very quickly, difference between opportunity to customize, like really as I want it to be mine, like that can be something that is empowering, but of course we don't want overburden, so that's an interesting trade-off. But I think it can also be empowering to be able to customize. So that's the flip side.
Right, you want to say anything? Sure.
I think if I understood the question correctly, not everybody in the blindness community is as excited for this AI as I am, and other tech enthusiasts are. I think there's probably a good portion. There's no burden. I mean, it does get a little silly, but I guess you get it. Every single time you use AI, it's, how was this? What did this do? It's give feedback. And I mean, I am burnt down on feedback just from all the crap I order on Amazon. How was the driver delivery? How was this? But so I get it. I mean, everything nowadays, it seems like everybody is gathering feedback and about every little thing. How was every freaking doctor's visit, you get a text and everything. So I don't think it's a burden. I think it's just the way we've gone with data collection being so key to the development of this. And the people that are enthusiastic about it, I think they won't look at it as a burden at all, helping collect the data.
It's actually what you're saying there triggered a memory. Like an old a web search class I took with Chris Manning years ago. And like one of the things he told me about like the history of like searches, like some actually the earliest search engines before Google had you actually input user preferences and say this worked well, this didn't work well. And people kind of didn't like it, was annoying. You had to put in so much work, it got exhausting after a while. And Google was able to sort of like crack the problem by one, leveraging unstructured instead of structured search, but two, figuring out ways to like approximate human feedback without actually asking for per user. And I do wonder maybe like if we figure out some ways a community to do that for all of these accessibility things will solve the problem.
Personalized page rank, right?
Yeah, so I've worked on click-based various ranking. I'm from Yahoo and Microsoft Bing. So there are two ways of doing. One is you take web search logs with clicks, etc., and that nobody knows. And you same thing with ads. and you create the models, that's your feedback model. There's one issue with that though, which is it's a looking back model where because it already that product needs to be online. If the product is not online, obviously you cannot get a log or click. That's where what I was asking earlier, where you ask a question, what you're doing, then those are the question answers where what should you be building?
So feedback solves the whole problem.
That's right. So if you already have something, then you collect logs, and then it's not a burden on the user. And so the only thing is here, all the apps that Brian is using, that data is behind a walled garden, right? You don't have access to it. So you'll have to create a new app and probably leave it up.
I wonder if something like reward models would work, like for language, like we have reward models that like sort of just assess the quality response. They don't ask for human intervention. I wonder if something that like could judge like how sort of like
yeah, we take time. How long did they respond? Did they need it? So for example, in Bing, we would look after typing a query, they just type in Google. So that the answer was so terrible. So we call it switching queries, right? So they want to switch the search engine.
I love that. So I was gonna say, like, I think like the challenge with a lot of these feedback, right, or like these things of feedback is like they're often feedback within the context of the current paradigm. And that can be really tricky when maybe the solution is some different.
Got it.
Yes, quick thought. So like, I'm not speaking from the position of expert here, but I was thinking if I know exactly what I want, even knowing what the problem is, I want to help, right? So I was wondering whether we can think about how by like people with disability could imitate, like say you want to collect data, imitate the scenarios that you don't have disability, but you have to go through this and then kind of collect data that way, right? So you don't have to shift the burdens to all the people like with disability.
Sighted people,
right?
Sighted people mimic.
Right. And I'm sure like I saw in the Elisa's talk that she has experiment like that. I remember like baby stories, or maybe your paper has kind of like kind of blur the images, right. And things like that. And but I guess we have to know, right, kind of what exactly we need to do there. And maybe this is related to your like scaling up the data question as well.
So just to warn anybody in this room, this particular approach is fraught with peril. Not that you can't use it in targeted ways, but you have to really know what you're doing. So this whole idea of like blindfolded participants is kind of like it's almost like the third rail of accessibility research for good reasons, like have been mentioned around nothing about us without us and making sure you're actually involving people with disabilities. Sometimes carefully, just so you all know that. So, okay, so I know we're way past time. Lots of great discussion. I'm going to try an actual rapid fire. Okay, so as you're packing whatever, panelists. All right, so imagine it's 2025. We're at VizWiz Workshop 7. I don't know. Would it be 7? What's the biggest thing that you think will change in a year? Because I think we did this last year and we were all pretty much wrong. So you can be wrong. It's only it's recorded, but probably nobody will go back. Probably only the next GPT, whatever, will review that information. So, all right, I'm just rambling a little bit to give you a little bit of time to kind of get your thoughts together.
I got you.
One sentence.
Video privacy personalization.
Video privacy personalization. Cool.
Do you want to go first?
The question is, what will happen in 2025 at the
You were a panelist. You're a panelist on a research workshop. I've kind of set the 1 year, but your prerogative is to say whatever you want, really, because that's what panelists do. So 1 year from now.
structure image generation. I just make that up.
Structured image generation, awesome. User interfaces.
Benchmarks.
I think human computer interaction. I think using computers navigating the web will become significantly easier for blind and low vision community over the next year.
Eventually, you made an AI pin and what a disaster that's been. Hey, maybe it'll be accessible a year from now. Computer vision, I guess hopefully a year from now, I won't need a real live person to navigate me the heck out of this building. I'll be able to fire it up on my glasses and have them tell me where I'm going as the gems.
Awesome, okay, so thank you so much. My prediction, by the way, 2025, we're gonna solve conference AV systems. Do we want to, Donna, you want to say bye? Okay.
Enjoy lunch.
All right, thanks, everybody.
Would you like dinner today?
Yes, I will.
Oh, my,
Congratulations. That was a great job. Oh no, battery. So let's go ahead and pause. Did you already stop the recording?
So many things I use that for.